So how many people have ever gone to like an open source project somewhere and they go to the landing page and they read the whole landing page and then they ask that question? Okay, that's what I'm here to try and hopefully fix. It's all about how to make your open source documentation not suck. So if you're working on an open source project, your documentation is going to make or break your project. And I want to hope that it's the former and not the latter. So I learned this by working on the hybrid cloud science data system at JPL. They went open source in 2017, and it had formerly been a private project before that. And so a lot of the documentation was very thorough for the technical side, but wasn't really geared toward an open source audience. And me and Kate were brought in as interns to kind of fix that. So what is HySDS? The hybrid cloud science data system is used to process all kinds of different scientific data into useful information. So one of the common ways they do that is with radar data. So you know, the Ridgecrest quake that happened a couple of years ago, ARIA, which is a project at JPL, was able to send a satellite over Ridgecrest and compare it to a scan that they had done about 3 months prior to that. And using the radar data, they're able to make an interferogram and see where the actual surface deformations are in the ground. They can use that for disaster response or research or whatever else needs to be done with that information. It was done through HySDS. So it's modular, it's versatile, it's can be configured to do any kind of processing that you need it to do. So for data scientists, we've got a view here. They can, there's all kinds of different variables that can change around to kind of make the data fit what they need it to do. And then for developers, it's a little more complicated. So this is the kind of stuff that we were confronted with right off the bat. And it's maybe not as friendly for some guy on the internet to run into. If you're a developer at JPL or you've been a long-time programmer, you can probably make sense of this. But I mean, we had like 60-page software design documents and all kinds of stuff. So that's kind of what it looks like for developers. Goals for the project: pathfinding. We don't want to get too crazy into it. We're part-time interns. We're only going to be there max 16 hours a week. You got to understand that we aren't going to be full-time. It's 16 weeks. We're not going to understand HySDS at the end of it totally. We're not there to write code. It takes them a lot of time to even onboard their own people, so we're not here to like completely understand the project. We're here to poke holes in the documentation and see what's missing. So got to keep it reasonable. First stage was research. So we went to write the docs. They're an open source community that is all about documentation and how to actually write good technical documentation. We went to other projects from JPL like OpenMCT and Cumulus, which are have really good websites, really good documentation. So we kind of see what JPL already does with their documentation and try and follow in those footsteps. And then finally, we were doing a Confluence wiki, which is how we were going to actually host all the documentation. So we had to figure out how to use Confluence. We went to WikiWeb to figure out how to use a wiki and what's expected for a wiki, what you're supposed to find. We had a bit of work cut out for us. So Kate actually went and mapped the entire wiki as it existed. So she actually did this all by hand, which is a little crazy. And we just visually mapped out how the wiki actually looks and how everything is organized to begin with. So what are we actually working with here? We were working on design, approachability, navigation, organization, maintainability, and consolidation. All of our documentation was spread over 3 different sources. We had a Confluence wiki, we had an internal wiki at JPL, and then we had another website that was hosted on GitHub. So there was no one place to actually find like an authoritative source on HySDS. So it was kind of up to the developers to like know what's current and what's not. The whole internal wiki is about twice the size of the public wiki because there's a bunch of projects that are developed for JPL and weren't public, still aren't. So there's a ton of stuff on there that never made it onto the public wiki and probably won't. And then you had this whole other GitHub website that had a bunch more documentation. It had some of the same documentation, it had new documentation, and there's just nowhere to really go. We tried to think about information access, converting users into contributors, into authors. So you should be thinking about when you're writing your documentation how to make it as easy as possible for someone to figure out what your project is and then transition to actually using the project and then transition to actually contributing to the project and writing their own documentation. There's a cycle there that's clear with every project, and you should be thinking about that when you're writing your documentation. Approachability was something that I personally worked on a lot. So if we actually go over to the wiki, this homepage, this landing page was kind of my baby. I spent a lot of time going over what was already there, not understanding it, asking lots of stupid questions, and then once I sort of wrapped my head around what HySDS is, writing my own layman's version of what HySDS is and trying to explain that to people. The part that I didn't realize was I got like 3/4 into the internship and finally actually showed that landing page to somebody else and they didn't understand. So none of that really, I got all the way into that and realized that I was sort of not headed in the wrong direction, but I needed more. And that's why I included the real world example here, which is the Ridge Quest quake that we had talked about. Including an actual example of what your project does, even if it's something like HySDS where there's tons of different versions of what it does. If you have just one concrete example of here's something we did with this project that can help people really understand where you're coming from, it's even better if they can run it. So if you've got a simple guide, even if it's not necessarily the quote unquote real thing and it's more of a simulation of what the thing actually does, if someone can actually run your program or run your project or solve a problem with it, that's going to help people understand a lot. HySDS is not super applicable to that. It's difficult because the whole point of HySDS is that it runs in the cloud. So unless you're familiar with AWS or you have money to spend on AWS, you can't really take full potential of HySDS. But there's versions of it that you can like run on your own laptop. And that was a big thing that we were pushing. Let me get back to my slides. People are always looking for FAQs, guides, and getting started. That was what we figured out was we started to get the wiki together and then we started handing it off to people. And the first thing that they would do after reading the landing page is look for an FAQ, look for a getting started, and look for guides. That's expected for any and every open source project. So if you're missing those, start writing them. Even if you start a project, start writing those immediately. If you've got somebody else that you're showing to your project, have them start a Google Doc and write down questions as they come to mind. That was something we started doing a lot as other people would start onboarding onto the project, and we would literally tell them, write a Google Doc, and every time you have a question, write it down. And once we had 2 or 3 people together, we could start seeing which questions everybody's writing down and start forming an FAQ based on that. So you should be writing that kind of stuff from the get-go to any project. Even if you never think it's going to see the light of day, start there. We worked a lot on navigation, and as you can see, it kind of, we started out with what we already had, which is more on the right side here. It ended up kind of splitting into 2 halves of the wiki. There was a half of it that was more for the technical side, and then there was a half of it that was more for visitors and like getting into understanding HySDS. It wasn't something that we planned. It was something that kind of ended up that way. But I think it's a good way to build a wiki for a project. You have your half for new users, and they can sort of go into the rabbit hole that way. And then once they get through that and they start to actually understand, they can start heading over to the more technical side and getting more in-depth. A lot of the stuff that's on that left side is stuff that we either wrote or we told people to write as interns. Again, with the scope of the project, I don't know how to write a contributor guide for HySDS, and I'm not going to know how to write a contributor guide for HySDS. I don't have enough time for that. I don't work with the code, but I know we need a contributor guide. So I need to hand that off to somebody who's equipped to write that. Just knowing that you're missing a certain document is huge. Even if you know you can't write it, that's okay. But if you can hand it off to somebody and at least give them a solid concrete goal, instead of, hey, write documentation, you can say, hey, write this document. That's big. We spent a lot of time in meetings kind of, hey guys, I need a contributor guide, please, and handing that off to somebody. We wanted to highlight the content. So we spent a lot of time taking existing documentation and going, how do I organize this? Where do I put this? Where does it make sense for this to be? And that kind of links back in with how do people navigate the wiki? Where are they going to expect to find certain information? And you need to highlight that information in the places where you're expecting to find it. Whether that's existing stuff or new documentation that you have to write, a lot of the time you might have a couple articles that are already written, and you know there's going to be a couple in-between articles that are going to lead to that information. Maintainability was something that I worked on a lot. So I actually wrote a little to-do page, which should still be live. Here it is. And we came up with a tagging system for HySDS. We had 6 tags, which are delete, create content, unfinished, in progress, needs update, and OK. Every single article on the wiki should be tagged with one of these 6 tags. So obviously delete means I think this needs to go away. I'm not totally sure that it needs to go away, but I'm going to tag it delete, and someone who knows more than me can take a look at it and say, you know what, this is old, or we don't need this anymore, we'll get rid of it. Obviously, if you know it's not good, just delete it. But if you're not sure, tag it. Create content means that the page we know the page needs to be there, but it's missing content entirely. It's either a stub article or it's just said, I just made a contributor guide article, but there's nothing actually there. I'm going to tag it create content. Unfinished means that it has content, but it's not considered functional. So there's something there, but it's still not quite enough for anyone to actually use it. In progress means that the article is functional, but it needs some work. Needs update means that this article might be out of date, and no one's looked at it in 3 years, and there's been a lot of development that happened, so someone should probably look at this, make sure everything here actually still works. And OK means it's good. You're good. Then I started working with some of the tools in Confluence to actually keep track of all these articles. So I went and manually tagged every single article in the wiki. And if you actually change the tags on any of the articles, they will update here as you go. So this is somewhere that the developers can go and immediately figure out what articles are where, just based on where they are. And then once they update the tag, it automatically updates for them on this page. So that saves a little bit of time. I also ended up just putting some top priority articles here. So these are things that really are missing a lot of content and we really, really need. Bringing it all together. So these were our 3 sources. So we had the internal wiki on the right there. We had our Confluence wiki, and then we had the depreciated wiki. So this is what the original wiki looked like when we got there. This is where we got by the end of it. And this is what JPL has internally as far as documentation. There's probably 2 big reasons for that. One is that it has to go through a process to be made public, any of that documentation. And 2, it has to actually be useful for the public to see. And a lot of it is really specific adaptations of HySDS for some particular project, and it probably just isn't worth making it public because there's not a whole lot to gain. There's a ton of stuff in there that should probably be public, but again, there's a process. So you got to kind of weigh, does this thing deserve to be on the public wiki, or is it only really useful for the people in those projects? So that's a big part of why the internal wiki is so huge. We went through a lot of time just organizing, removing duplicates, tagging things, getting rid of old stuff, making sure stuff was up to date. That was a lot of our time. It ended up being 330 pages by the end, which is pretty good, I think. This is kind of a visual guide of what makes up the wiki as far as how many articles. So it's mostly guides, tutorials, and how-tos. And a lot of that is because that's the stuff that already existed going in. They had actually written a lot of really good documentation. It was the other stuff that needs a little work. Bringing actual outside contributors in was where we did a lot of our digging. We're still working on that. HySDS isn't easy to understand. It's not the type of thing that you can just bring somebody in on. Going into the project, we were hoping to get the wiki into the place where we could actually solicit outside open source contributors to the project, whether that be university students or other organizations that might be able to benefit from the project. What we realized about halfway in was we didn't actually have enough stuff to onboard our own people, really. So the second half of it ended up kind of transitioning into that, which is just get our own documentation good enough for our own people, and then down the line we can worry about actually soliciting outside contribution. So we got to get a roadmap going, which is something that we were working on with the team. Actually publicly announcing, hey, this is where we're headed with HySDS, here's how you can help out. Bringing in more interns, getting the FAQ page going, getting the contributor guide going. That's all the stuff that we ended up recognizing as top priority, but never having quite enough time to actually get it nailed down. There are interns that have continued on with the rest of this project after me, so they're working on a lot of that stuff. I won't do too much schmoozing, but JPL is pretty rad, and it's the people that make it that way. I spent a lot of time asking stupid questions to really smart people, and they never looked down on me for it. I spent a lot of time walking around campus and meeting people who didn't treat me any different after realizing that I was just an intern from the local community college, and were still just as interested to talk about what I was doing as when they thought I was a full-time employee. It's a very cool place to be. So I do have to thank Lan Dang. She was my staff mentor. She was the one who really made this whole thing happen for me. Without her, none of this would have done anything. I wouldn't have learned any of this stuff. So thanks, Lan. Appreciate you. If you want to get a hold of me, spencer.sullivan@gmail.com. Send me an email. Happy to answer any questions. You can also contact Kate. She was my co-intern. She was with me the whole way. She did tons of work on this project that I didn't get to. She's rad. So if you have any other questions, she's another person you can definitely ask. So thank you guys. Any questions?
So I'm sorry if I missed this talk. You said originally when you started you had 3 separate sources of documentation. You had Confluent, an internal wiki, and basically like the external documentation.
So he's asking when at the beginning I had mentioned that we had 3 separate sources for the documentation. So those were an internal wiki at JPL, which is on their intranet. So you can actually only get to that if you're at JPL and have credentials. We had the Confluence wiki, which is what we worked on. So that already existed when we got there, and we just reformed it. And then we also had a GitHub Pages website. So that was actually hosted on the GitHub for HySDS. And we ended up basically nuking the GitHub Pages because at the time, we have plans for it in the future, but it ended up just causing more problems than it solved. and just consolidating down to the Confluence wiki and some of the stuff that still exists on the internal wiki. But the developers at JPL should now be contributing full-time to the Confluence wiki. So in a sense, the internal wiki is kind of retired, except for the internal projects that are still going on with that. But anything that's just the general HySDS core, it should all go to the public wiki. So that's the authoritative source.
So you still maintain the internal wiki, that didn't fully make its way into Confluence? Is that?
Yeah, so lots of stuff that was in the internal wiki didn't make it into Confluence, mostly because it was stuff that didn't make a whole lot of sense to be on the public wiki. There's a lot of just really specific adaptations, and that stuff I believe is still being maintained by the teams that work on it.
I was asking because we have a similar situation in that we have like an external wiki and we have an internal documentation repository. We've been looking at putting it all in one place, but then limiting based on like access restrictions, like you have to log in to see this page or that page. And I was wondering if you played around with that in Confluence.
It wasn't something that we played around with Confluence just because the Confluence wiki was meant to be a fully 100% public source of information on HySDS, and they already have this existing internal wiki, so it's kind of anything that they plan on being internal would just go on the internal wiki. But I'm sure there's ways you could do that in Confluence. There's tons of tools that I never got around to using. I'm sure there's ways you could do that.
Comment on this because I do a lot of research in Confluence Wiki, and you have to understand that the Confluence Wiki permissions are inherited. So unless you lay out your structure correctly, you're going to have to go in and explicitly give people permission to access certain pages forever.
Right.
Yeah, it might even be more useful to have a separate source, like have your Confluence wiki for whatever everyone is going to be able to see, and then if you have some internal stuff that only certain people could see, it goes on like a separate website or some internal resource or something. Anyone else?
If you don't mind me asking, what was the time frame you had for that internship, and did you show up with like a singular objective every day, kind of thinking, this is what we need to get done today, so we can start working on this tomorrow?
Yeah, so he's asking what was the time frame for the internship and what were like the daily goals and things like that, I think, right? So 16 weeks was the total, 4 months. It went along with our semester. It was actually, the internship was done through Pasadena City College. So it was meant to coincide with one semester because I was getting school credit for that. We set the initial goal that someone should be able to stumble upon the wiki and reasonably understand HySDS within 1 week, I believe was the original goal. I don't think we're there yet. That, like I said, that goal kind of shifted halfway into the project. Everybody knows you start a project and you set your goal and then you follow the plan, and then at the end it works, right? And you get your goal and everybody's, maybe not so much. So the goal kind of shifted as we got into the project. We spent a lot of time sitting in Lan's office and talking about deliverables, and she was with me every step of the way. Lan's office was where we would do our work for the most part, so she was there every day to kind of direct us. So if we have any questions, that's where we would go, and that's where we did kind of our planning. There's definitely some times when me and Kate were a little lost as far as like what direction we should be headed. We had all these problems we needed to fix, but where do we start? And that's kind of where Lan stepped in and was like, hey, do this. And, in the end of 2 weeks, you should have this. So we set kind of a general goal and then did some research and then started setting deliverables. That's how it ended up going. Anyone else? All right. If you have any other questions, feel free to talk to me once I'm done here. Thank you.
Okay, well maybe we can, wow, that's really loud. Can we adjust the volume for this?
It actually needs to be that loud so that it can
Okay, got it. I'm generally kind of a loud person, so I'll do my best to not blow everybody's eardrums off. So hi everyone, thanks for coming today. My name is Stephen Yu. I'm a solutions architect at Databricks. Today we're going to be talking about building better data lakes with Delta Lake and Apache Spark. Before we begin, just to get a feel for who's in the room, how many folks know what Apache Spark is or use it in production today? Okay, awesome. How about Delta Lake? Do you use Delta Lake or do you just heard of it?
I just know what it is.
Okay, awesome, awesome. And then, so this is a smaller group. Feel free to keep this interactive. If you have a question about something I said or it didn't make any sense, feel free to interrupt me and we'll have a discussion about it. Time permitting, we can do like a little interactive demo at the end. So if you want to, pull out your laptops and, follow along, please feel free to do so. Okay. So let's, before we dive in, sort of want to talk about, the whole premise of the data lake. I actually spent a really long time at Teradata doing benchmarking and performance tuning. Back in, 2010, we started noticing that benchmarks started to dry up. Customers were saying, okay, well, hey, there's this cool new thing called Hadoop and this concept of a data lake. And I'm told that I can store not just the structured stuff that goes into the data warehouse, but I can also store, unstructured data, semi-structured data, JSON data. I can take all of this stuff and just kind of put it into my data lake and store it forever, right? Back in 2010, we didn't quite know what that meant. What are we going to do with this data later? Okay, well, ultimately the goal was we're going to do some data science and machine learning on it. But back then, the plan was, all right, let's take all our data, put it all in the data lake, and we'll figure out what to do with it later. The problem with this approach was that you ended up collecting a lot of garbage data. Right? You ended up with processes that would take data from your source systems, fail to kind of like clean things up and normalize things, dump everything into the data lake. So garbage in, garbage stored, and later, a few years down the line, data scientists started to go and look at this data and go, hey, let's actually do some machine learning on this. Wait, the data's junk. Half of this is corrupt. What happened? So does this actually resonate with some of you? Have you been through this journey of building a data lake and failed miserably? Kind of, sort of? So I mean, let's kind of dive into what that means, right? What does a typical data lake project looks like? So I actually used to also work for a mobile gaming company, so we can sort of use that as an example. Let's say you have a whole bunch of streaming data, event-based data. Maybe this is data that's from your cell phone, you're interacting with an application or with a game or something. You have a whole slew of event data that's coming into, say, like a streaming message bus like Kafka. And you decide, okay, well, what am I going to use to process this data? And you go, okay, I heard about this thing called Apache Spark. Has connectors to Kafka, has this thing called structured streaming. We can use this to do some streaming analytics. But what if I wanted to sort of reason about data that's older? Like streaming data is more about near real time, what's going on in the business right now today. What if I wanted to understand what happened last week or what happened a month ago? And so that's challenge number one. How do you do historical queries in this sort of an environment? You build out this thing called a Lambda architecture, right? And basically you have a speed layer and a batch layer. You have all this data coming into your speed layer, and periodically you take this data and you move it into a batch layer. You marry the two with a view on top or something, and then that way you can sort of have a view of what's going on in the business in the last hour, as well as let's persist all the data that we've gotten so far, write this out to data lake. And then, of course, you can also use Apache Spark to process data that's sitting out on the data lake if you wanted to do any reporting or BI, SQL analytics afterward. But that leads us to challenge number two. What happens when there's messy data? Like schemas change, file formats, or rather data is inconsistent. I've seen this over and over with customers. Is after they've started building this out, they go, "Hey, the data in my speed layer doesn't quite match batch layer. Something's going on here. How do I start enforcing like quality of the data that I'm actually looking at?" So you come up with a framework to start building like custom validation rules to try to make sure that your data is consistent. Right? Okay. So step one was to build a Lambda architecture. Step two, start building validation patterns to make sure your data is kind of consistent. But how about challenge number three? Turns out software can have bugs. So you might have upstream changes with your platform team. You might have upstream changes that kind of break your data. So how do I go and reprocess this stuff? How do I go and say, oh, platform team said they released a software update that caused a bug, and now we have a whole bunch of bad data. We got to reprocess last week's worth of this type of event data. How do I do that? So, you come up with a scheme to go, okay, well, since Parquet and ORC and other Hadoop file formats are pretty much immutable, let's come up with a partitioning scheme. Let's say we partition our event data by date. And we'll just go and reprocess that data for that entire day or that entire week. Okay, but fine. We figured out a reprocessing framework. But what if you wanted to go and perform some updates to this data? What if you're doing like change data capture and you have to go and update data that's sitting out in your data lake? That's another thing that's not inherently supported in the big data Spark paradigm. So you have to come up with some more creative ways to do things like updates and merges, pretty much following that same pattern that you were doing with the whole partition replacement and whatnot. Since Spark or Hive didn't actually support transactions and ACID and the ability to do updates or deletes. But let's say you're running the DevOps team, you're the data engineers, you have downstream consumers. Like, when do I actually find time to do all this stuff, right? Because the system is not atomic, it's not isolated. There's no ACID, right? There's no ACID in a data lake. So if you make changes to your underlying data, it affects the downstream readers. And again, if something happens during the middle of job processing and a job fails, you might have inconsistent data that's written out. So you got to find time to do this like on the weekend. I'm sure you've all been in a situation where you have to write an email that says, hey, yeah, system's not going to be available between 12 a.m. and 3 a.m. on Saturday morning because we're going to be doing some updates. So, I mean, ultimately, what this ends up being is you spend a whole lot of time and money just solving systems problems and not actually deriving value from any of your data. So, what does this mean? If you take a look at what actually happens in this model, there's no atomicity, right? So that means that, as I mentioned before, you have a production job that fails, right? And you've written out your table halfway. Or maybe it's written out some corrupt files and now all of a sudden your entire table is not readable. Okay, there's no quality enforcement, meaning if platform team decides to change the schema, introduce some new data types, introduce some new columns, and forgot to tell data engineering, then that might break some things downstream. No isolation or consistency, right? So there's no way to really conveniently to have multiple writers and readers appending to like the same table. You have to come up with things like the Lambda architecture and then ETL processes or Spark jobs that go and try to make things consistent. So this is kind of like, this is where the Delta Lake project comes in. Okay? Basically, you take this architecture and you simplify it, you distill it down into something that looks like this. And so you can kind of see data moving from the left to the right. We call this a medallion model. So you can think of it as increasing incremental levels of data quality. And so you take source data on the left from Kafka or Kinesis or maybe even your existing data lake, and this is kind of the important point to make here. Delta Lake doesn't replace a data lake, it sits alongside it, it can consume from it. It basically gives you a layer on top that enforces quality and schema and all sorts of things, and we'll go into how that actually works. Let's start with what you typically see in the bronze layer, the raw ingestion layer. Right? This could be, let's say if you're consuming from Kafka, this could be a Kafka message that comes off with the schema of a Kafka message. So you have something like a topic or a partition ID, maybe the sequence that was last read, and the actual payload in maybe like a JSON blob. Same thing for Kinesis. Maybe if you're ingesting things directly from your data lake, this could just be take your JSON data and we're going to convert it into Delta. And think of each one of these sections as like a SQL table almost. You're writing data to a raw table, and then you're moving data from raw into silver, and you're moving your aggregated or clean data into gold for your business level reporting and aggregation. Silver would be that place where you basically take all of your raw data, you clean it up, you do your deduping, you make sure that your column names are normalized, the data types are correct. And this is kind of like the basis for all of your downstream aggregations and summaries and whatnot. If you ever want to come back and look at what the quote-unquote raw data look like, but after it's been cleaned and normalized, this is where your organization would come in and say, okay, this is what the data looks like before I summarized it. And then of course, gold is typically what you would do within data warehousing land. You use summary tables, aggregations, what you open up for BI tools. Maybe you consume this using Spark SQL or even Presto. Questions before I continue going? The slides actually are available on the SCaLE website. Okay, so we talked a lot about moving data between these different levels of data quality, these different delta tables. How do you actually do that? So believe it or not, you can actually use structured streaming to move data between different delta tables. Now you go, okay, wait, why am I using streaming? Isn't this more like a batch process? The cool thing about using delta with Spark, especially with structured streaming, is that you can use the built-in things that make this processing much easier. Like, how do you keep track of what files have already been processed? How do you keep track of new records upstream? How do you automatically propagate those changes? And how do you ensure exactly one's semantics? Instead of having a streaming job that runs 24/7, you can actually set streaming jobs that say, hey, let's go and process all the data that I haven't processed since the last time I ran this job. You can create structured streaming jobs that say, hey, trigger once. Read everything in, write everything out to my next level, and then shut the job down. We'll schedule this to run once a day, once an hour. And then you can just kind of avoid the whole headache of, okay, how do I actually manage what's been processed and whatnot? Kind of obfuscates all that complexity out of like building pipelines that move data between your different levels of data quality. On top of that, because Delta Lake introduces the whole concept of ACID compliance to your data lake, you can now go and do things like updates and deletes and merges at different levels of your Delta tables. And we can I'll actually walk through how Delta Lake works under the covers in a little bit so that you understand how you can actually do these things with immutable data formats like Parquet. I mean, this is especially important now that we have CCPA in California. So if you get a request for a DSR from a user, you can go in and say, okay, well, I'm going to go and delete all data with this user ID. Okay? And then finally, of course, because software isn't without bugs, it's really easy to use Delta to recompute tables. You can go in and say, I want to delete all of this stuff, or I want to delete all of this event type, and I want to reprocess it. I want to restart my streams. And then you can start from your raw layer again, take all your data that's been persisted again forever, and then recalculate and recompute everything without really affecting any of your downstream users because you're doing everything using ACID transactions. So I want to quickly touch on some of the folks that are using Delta Lake today. We say this all the time and this never changes. There's been more than an exabyte of data that's been processed through Delta Lake in the last month. Some of the really popular ones that are here in Los Angeles that I work with personally are Jam City and Riot Games. Wanted to kind of zero in on a couple of the use cases. So Comcast is very interesting because it actually follows that bronze, silver, gold medallion model. Basically what they do is they collect a whole ton of data from those set-top remotes, which then goes through this process of cleaning and aggregating and filtering. And the end goal is basically to build machine learning models to improve their speech detection algorithms. They had this running on Spark without using Delta Lake, but they had to split this up into like 10 different Spark jobs, following that whole crazy Lambda architecture and whatnot. They took like one query and they had to partition it out across 10 different clusters, but they switched to Delta, and they were able to they were able to reduce the compute capacity or the power that they needed to run these jobs from 640 instances on EC2 running on AWS down to 64. Basically, all that time not spent managing these extra jobs is time they can now spend innovating. Sam's Club is another really interesting use case. They have, or use cases, they do everything with Spark, including like finance to forecast sales and wages, assortment, so that's stuff like how do we decide what items to physically sell on the finite amount of shelf space that I have in a store. They have sales tools that help them determine, how much to produce on a given day for fresh items like, rotisserie chicken or fresh meat or how many muffins to bake. You don't want to make too much, or you don't want to make too little. And of course, your standard gamut of fraud engines and personalization and recommendation systems. The goal for them was basically to migrate from an on-prem system into the cloud, because the cloud is the future for them. And they used Airflow to orchestrate a job that takes data from Teradata on-premise into Swift object storage, which then triggered additional jobs that moved this into Azure Blob Storage, and then into multiple Databricks workspaces in running in Azure. Super easy with Delta because it's really easy to create tables and update them and delete things. Basically, before Delta, they were trying to build this in-house solution that did that whole partition swapping shenanigans that I tried to explain earlier. But because we have transactional updates with Delta, this greatly simplified their pipelines. They actually had queries that did basic aggregations that, like figure out retail sales over the period of 1 year. This improved from before Delta running over an hour down to less than 6 seconds with Delta. And just to kind of give you an idea, that same type of query ran on their Teradata system and it took 30 seconds to execute. So how do we actually get started using Delta Lake? It's actually quite simple. It's been published as a Spark package, so you can say, PySpark -- packages and then include the version of Delta Lake. You can use Spark Shell with the same -- packages. You can include Maven dependencies, add things to your SBT build file and to your pom.xml, and include Delta Lake into your projects. And to get started, it's actually, think of Delta Lake like a file format. So instead of saying dataframe.write.format Parquet, say dataframe.write.format Delta. That's pretty much all you have to do to get started. One thing I did wanted to bring up that's in progress now is a new feature called declarative pipelines. Basically, this allows you to enforce, not just necessarily things like schema, but end-to-end, like, okay, where's my query, where's my data coming from, right? Where are we storing this data? What should the schema look like exactly? If you're using a Hive metastore, what should the table DDL look like? What's the description for the data that's coming in? You can tag all of this data as it's coming in, and then you can additionally start setting expectations on data quality. So sure, you can do schema enforcement, you can do data type checking, but how do you do invariant checking? Like, what if I want to know that data that I'm getting is in a certain range value, or the data that I'm getting is not from 1969 because there is some problem upstream? And then once we figure that out, what do we want to do with that data? Do I want to fail my pipelines? Probably not, because you get a lot of bad data in production pipelines, and you have jobs that are just failing every 10 minutes. Maybe you want to set a threshold for alerting. So maybe if 10% of my data is bad, I want to send an alert. I want to let somebody know that, hey, we're getting more data that's bad than usual. Or maybe I want to just go ahead and quarantine that data into another table so I can go and take a look at it later. All of these things are things that are going to be supported in declarative pipelines. That's probably going to be available in the next couple of quarters with the release of Spark 3.0. Okay, questions before we dive into actually like how Delta Lake works under the covers and what you might see when you take a look at the internals of a Delta Lake table? Is everybody just completely lost, or is this making sense?
I had a
Okay,
question.
just checking.
I had a quick question. You said that Sam's Club had a query that in Teradata took them 30 seconds.
Yes.
They moved to Spark. It took them over an hour.
Yes.
And then they moved and then got to, why did they move to Spark if it took them over an hour in the first place?
Well, so Teradata was on-premise. They were trying to build these systems in the cloud, and they were trying to see if, oh, do we need a cloud data warehouse, or can we run everything with Spark? So initially, they tried using Spark, and they said, oh, this kind of sucks. And then we said, use Delta. And then, I mean, it was a problem of optimizing on I/O. And Delta, I can explain that later. Delta helps you basically rapidly eliminate the amount of I/O that you have to do so that your queries run faster. Great question. Okay, so how does Delta Lake work under the covers? So if you take a look at Delta, right? Basically, Delta tables, just like Parquet tables or ORC, get written out to disk, right? And this is kind of like the file tree of what a typical Delta table looks like. So you have a transaction log. This is how we achieve ACID compliance. Inside that transaction log, there are different table versions. These are JSON files that represent what happens or what happened inside that specific version to create that version of the table. And of course, there's options to still use partitioning like you would in Hive or in Spark SQL. But we say this is optional because Delta actually has some tricks so that you may not necessarily need to partition your data to get optimal I/O elimination. You can kind of reason about what a Delta table is just by thinking about it as a set of actions. So let's say you have, we had those different versions of the table in the transaction log, and you had information about what happened, what changes happened to my data to create that version of the table. So that could have been a change in metadata. That could have been, okay, I renamed this column. I changed the schema a little bit by adding columns or removing columns. I changed the partitioning scheme. So a change in metadata. And ultimately, when you append data to a table, you're adding files, right? If you're updating or deleting, you're essentially adding new versions of a file and then marking old ones for removal or deletion. So ultimately, a transaction log shows the current metadata, the list of files that belong to that snapshot of the table, along with like a list of transactions and versions and whatnot. So you can think of the changes to the table as atomic units called commits. So in version 0, we added these two Parquet files because we appended this data. Okay, and then in version 1, we updated something, or we deleted a user ID or something. So we needed to restate Parquet files 1 and 2, and we created another version, Parquet 3. So when we go and query that table, we see that, oh, in version 1, we only need to read 3.parquet. Okay? And then you have to make sure that if there are multiple users, multiple writers, multiple readers acting on this table, that there is some level of consistency. So let's say you had user 1, and user 1 created version 0 of the table. So they did the create table, and they inserted some data into it. Then user 2 went and added some data to that table. Delta should know that if user 1 and 2 try to modify the table again, that they can't both create a version 2, right? If user 2 created version 2 first, then user 1 should create a version 3. So this kind of leads into the next discussion of how Delta solves the whole, concurrency issue. Like what actually happens if two writers try to update a table at the same time? So what happens is, two users are trying to make a change to this table. They both see that there's version 0 of this table, so they both record a start version. And then the job starts, right? And then you go within the jobs that are running, you say, okay, well, I'm going to do something like I'm going to read the schema, and I'm just going to append some data to this table. And they're both doing this, and let's say this is like 2 different streaming jobs that are writing to this table, right? And then as soon as that batch is complete, if somebody goes to attempt to commit some data, the first person there will win. So user 1 in this case created version 1 of the table, and then user 2 goes and tries to run version 1 and says, hey, wait a minute, table changed. So we should actually check to see if there were any changes that might have affected what I read. Since in this specific example, we only read the schema and we were appending data, we weren't updating, we can be confident that none of the underlying data changed. So then user 2 automatically goes and creates a version 2 of the table. So in database world, typically you do locking, right? Like if you're trying to update a table, the writer locks the table and everyone else has to wait for that lock. It's more like a pessimistic concurrency model. In Delta Lake, it's, we'll both assume that I'm the only one writing to this table, but I'm going to check again before I commit that data to see if there have been any changes. And if there were, if the changes did not affect what I read, then I'm just going to go ahead and append as the next version of the table. If there was an update and it affected what I read, then recompute.
Why? Like, why wouldn't you keep the pessimistic locking thing? Like, especially if your company's data depends on this, why would you allow people to potentially screw this up?
Where would you manage? So because it's a distributed system and you're using multiple clusters, your writers don't necessarily just exist in one system, right? So in a database, everything's happening, everything's managed by one database. In the decoupled compute from storage world where you have data out on S3 or on Azure Blob and you have multiple different systems and clusters trying to access this data, who is managing the central locking? That's why.
So then somebody has to also manage the who wins, right?
Right, but that is managed by the individual clusters that are doing the writes, right? Because right before, let's say user 1 and 2 are committing data, user 1 finishes first, user 2 doesn't know that, right? It only goes to check to see if this was committed before it tries to write. So there's a central transaction log that's sitting out on blob storage. And then each of the readers and writers are responsible for checking the transaction log to make sure there have been no changes. There's no central system that says, hey, you can't do this because this has changed. It's, I'm going to see if I can do this before I try to do it. Does that make sense?
It sounds like you're moving the lock to after the transaction instead of before. And you're still using a centralized determinant of whether or not who wins and who loses.
Sure, but nobody is actively managing locks.
Okay.
So I think the confusion is this is a form of optimistic locking, right?
Yes.
Academic papers, and typically you have two different writers writing different rows, and they're allowed to, and then
I'm going to give this to you because we need to hear it for the recording.
So if I remember correctly, this is a form of optimistic locking. It's written about in academic papers, but normally it's discussed in terms of row-level transactions. And so compared to the pessimistic locking, if you're locking at the rows instead of the tables, that's a lot of overhead. So the idea is to reduce the overhead at that level and do one check at the end. I believe, fuzzy on my memory there, but I think that was the idea.
Awesome, thank you. Cool. And then one more thing I wanted to point out, you have to think that, okay, you have all of this data that's sitting in these transaction logs. What if I have tables that have millions and millions and millions of files? Like how do we handle these JSON files that have all of these entries? And the answer is we actually use Spark for that, right? So you have these JSON files that say, hey, in version 1 and version 2, I added these files. In version 3, I removed these files. What Spark will do is periodically take all of this information and then distill these things down into checkpoint files in Parquet. So you'll notice that if you're running queries against a Delta table, there's actually another Spark job that goes and runs and parses and figures out, hey, let's cancel out the files that don't exist for this snapshot of the table and then figure out what I can read. So let's touch on roadmap real quick, and then I'll jump into a demo environment. We can actually go and run some code and see how this works. So, Delta Lake has come a long way since it was announced at Spark Summit in April. We initially added support for S3 and ADLS. Initially, it only supported HDFS. We added, update, delete, and merge APIs for SCaLE and Python. We also added vacuum for SCaLE. So you got to think that if you have an update that runs or a delete that runs, and now you have files that are deleted, they still exist on S3. And so now you have to vacuum them, like same concept of cleaning stuff up in like PostgreSQL or something, running a vacuum command. We also introduced convert to delta, which means you can take existing Parquet data and then create a delta table without having to create a new version or copy data or restate anything. And then, in version 5, which was actually introduced in December, we introduced Presto manifest. So now you can use Presto or Athena to actually query a delta table, whereas historically you needed a Spark-based system that could interpret how to read the delta transaction log. And then after Spark 3.0 is released for open source Delta Lake, we'll have support for DDL, so you can do create table and then have that managed by the Hive metastore. Right now, metadata for a delta table is managed by the transaction log, so schema information, column information, all of that is stored in the transaction log and not in a Hive metastore like it is for Parquet tables. And then there will be SQL-based DML support. Right now, if you wanted to do updates or mergers, you have to use data frames APIs. But you will be able to use SQL to just say update table set something or other, or merge into table, and then your conditions. Okay?
Quick question on this. Is
Yes.
so earlier in Spark's history, Python was always a second-class citizen, and then it became elevated to a more first-class citizen. Is SCaLE still the first-class citizen, or would you say that Python's performance is comparable?
Performance is identical. There are a couple of scenarios where Python might not be my first choice, not necessarily for Delta, but just for Spark in general. The most notable one is with UDFs. Right, if you're creating SQL UDFs and if you create SQL UDFs in Python, you have to serialize data in and out of Python process that's running on every executor, whereas if you wrote your UDF in SCaLE, that wouldn't be the case. Okay, if you want to get started with Delta Lake, it's an open source project. It's available at delta.io. That's where all of our documentation is, links to the GitHub repository, announcements about new features that are coming. So definitely check this out if you're interested. So the next part of the presentation is going to be more like an interactive demo. So again, if you want to follow along, let me actually start mirroring my screen. All right. There we go. Okay, so if you want to follow along, you can sign up for, I'm going to do this demonstration in Databricks. It's a quick and easy way to get started with a Spark environment. So if you'd like to follow along, you can sign up for the Databricks Community Edition. That's just at databricks.com. Try Databricks. Make sure you click on the Community Edition and not Free Trial. Free Trial requires you to put credit card information in. I mean, you can if you want, but it'll start billing you after 2 weeks. So Community Edition is what you want to do. Okay. So let's do like a quick run through of how I would interact with Delta Lake in Spark. So let's say this is the scenario. I can share this notebook afterward, and I don't know if there's a public place on the website where I can say, hey, this is the notebook that we used, or
I'll have to talk to Alon about that, but I don't think it'll be too much of an issue to just drop a notebook up there.
Okay, cool. So let's take a look at how to get started. So what I'm going to do here is set up some code paths. This is actually all writing out the blob storage. And then we're going to set some Spark parameters to make this configuration more friendly to run on a tiny cluster. Okay, so how do we do this with Parquet? Create a data frame, and we're just going to make up some data, right? So we're going to create 100,000 rows, and then we're going to split that into, let's think of this as like IoT data, right? So let's say it's like a door sensor or a door lock or something. There are actions like open and close, and then we're going to make up a timestamp for when this data was created. And so let's just go ahead and define that as raw data frame, okay? And then write this data out to Parquet. That's your typical run-of-the-mill data frame.write.format Parquet. We're going to partition this by date, and then we're going to save it in that path that we defined earlier. I'm happy to pause if people are actually signing up for the Community Edition and they want me to wait. I'm signing up right now. Okay. All right, sounds good. So, dataframe.write.format Parquet, and then let's just go ahead and quickly read that back in and see what the data that we generated looked like. So, I mean, it's super, super interesting data, right? It's open and closed with some fake device IDs and a date that this stuff was recorded. Okay, cool. I mean, what are some of the things that we can do with this data? We can do some simple aggregations, right? Let's say I want to do a data frame group by and count how many different actions there are. Not surprisingly, there's 50,000 of each because that's how we created the data frame. So what if I wanted to append some data to this table? So let's say that I'm going to create a read stream, and I'm going to start generating some new open actions. Okay, and I'm just going to generate some fake dates for this. And I'm going to start writing this out to the same path. All right, so this is just pretty basic, streaming data frame write. We're running this every 5 seconds and writing this out to that same table that we created earlier. So let's make sure that this is actually processing some data before we move forward. Okay, there we go. So every 5 seconds, we're going to start writing out hundreds of records. Okay, let's do another count on this Parquet data. Okay, we've had several batches of this being written. And then you go, well, okay, hang on, wait a minute. Earlier, we had 50,000 open actions and 50,000 close actions, and we were appending data, right? What happened? What happened to our counts? The problem with this is Spark's file sync implementation doesn't actually support batch and streaming. So you can't have a batch-based table and stream to it at the same time. It messes things up. This kind of goes back to that whole, got to have a Lambda architecture and got to have a streaming table and a batch table, otherwise things get messed up. So what if you were to do this with Delta Lake? We're going to do the same thing. We're going to take our raw data. We're going to write it out to Delta this time, and the only thing we've changed is the file format name. Still partitioning by date. Okay, and then we're going to be able to do the same group by aggregation so that we can see that we'll have 50,000 of each action. I should stop spoiling this and let you just see it after it runs. Okay, and then we'll do the same thing, right? We'll create another streaming data frame, and then we're going to write the delta. We're starting to generate more of the open events again. So let's wait for the stream to initialize and start writing some records. Okay, there we go. I'm going to let this run for a few batches so that we can actually see some interesting data being written out. Okay, and then let's go ahead and do a count. So we got some records that have been written. This is not very surprising. This is going to work. Spoiler alert. The other thing I'm not supposed to be doing is running these things live because you never know what's going to happen. But I like to live dangerously. But anyway, there we go. I wasn't lying. Now you can see the additional records that we're adding are actually showing up. And now we're streaming into a table that we've been doing batch operations into. Okay. Let's talk about using Delta Lake as a source because we talked about the different medallion levels of bronze, silver, gold, and moving data in between. So what does that sort of look like? You can use Delta Lake as a source. And so instead of just using Kafka or something, you can say, oh, let's do a read stream from this Delta table. Okay, and then you can use that to, let's say you're moving from like silver into gold, and so you wanted to do a basic aggregation that counted all the different actions and dates and device IDs. Okay, so define a simple read stream with your Delta tables as the source, and then take that data frame, do your typical standard Spark data frame aggregations, and then write that back out to what you now consider your next level of aggregation or your gold version of your Delta table. Let's go ahead and let that process a few records. And let's see if we've gotten anything yet. Any questions while this is running and combat the awkward silence? Cool. Okay, so we've got some records written out to our gold path now. If we run this query again, you'll see like additional data that's been written to this table. There we go. All right, let me go ahead and cancel this. All right, so let's talk about schema evolution. We talked about what do we do if the upstream data source changes, their schema and forgets to tell us. You notice that, okay, let's say I was a platform team and I introduced a user ID to this schema and I forgot to tell data engineering. Delta will actually fail that job and say, hey, wait a minute, we've detected a schema change upstream. Did you mean to do this? So this kind of goes back to the whole, garbage in, garbage out thing. If you try to build your data lake to be too permissive, then you end up with unexpected changes. And so you can actually have Delta automatically support schema evolution, but by default, the jobs will stop and say, hey, there's been a schema mismatch. If you want schema evolution to be automatically supported, you actually just create the right stream with an option called merge schema equals true. And then it will allow you to write the schema changes. And then when you take a look at Delta table, you'll see, okay, well, in my latest version of the Delta table, there's a new column called user ID. But previously there wasn't, and that's kind of where the whole time travel thing comes in. So time travel is kind of like a happy consequence of the whole data snapshot transaction log model. I told you that there were increasing versions of this table. So there's version 0, then we added some files, there's version 1, we added some more files, we made a schema change, there's version 2. So let's take a look. This particular table has 19 different versions because every iteration of like a streaming query was a new version of the table. I know that I probably made a schema change before version 2. I actually don't know that now, but it's a wild guess. And so let's take a look at what the table looks like right now. And rather, it'd probably be better if we just did a count of how many records that we had in the Delta table right now. I should also stop these streams so that I stop adding more data to this. Cancel that. And I'm going to cancel that. All right, so table looks like this. Right now, there's a user ID column now that we added. And total number of records, 130,000. But what if we wanted to see, what did the table look like before we made that schema change? So I can actually query this table by using version as of. And say, you can see for version 2 of this table, there was no user ID. And likewise, if you wanted to see the count of records that was in version 2, same thing, version as of 2, it was only 100,000 records in here instead of 130. So Delta Lake allows you to travel back in time, so to speak. This becomes immensely important, not necessarily, as a data engineer, if you submit an update or a delete and forget to specify the appropriate predicates. But if you were doing something like machine learning and you wanted to, all machine learning it's important for you to understand exactly what versions of the data you actually use to train your model. So you can actually set up things like MLflow to point to exactly what version of this data set at this table at what point in time that I use to train this model so that you can have reproducible experiments.
Can you check to see, I need to know, there was a version change 2 months ago, but I need the data in the intervening 2 months in that particular version that it was in 2 months ago, or is that not available?
Come again?
So let's suppose somebody admits we added the user ID field 2 months ago.
Uh-huh.
I need the other 3 fields for data today, up to today, for the intervening 2 months. How do I get at that?
So you added the user ID 2 months ago.
Yeah. And so like if I could put it in, you, as you said, to use ML flow, I would just keep pointing to the table and just say like, I want data from in this version.
Right.
Just give me the data in that version, regardless of whatever happens later. That will work.
Right.
Okay.
Exactly. It's exactly that version. Not any data that's been appended to since, but the snapshot of the table from that point in time.
Is this enforced by like a schema registry, or where is this? How is this enforcement?
So that's in the transaction log. So let me show you something. And this is something this is describe history as a SQL command that we just introduced in open source. Let's see, Delta Silver Path. Where was Delta Silver Path? Here we go. So this is the actual location of where I've written this data out. So if I wanted to see the history of this entire table, I can just do delta dot path. And then you can see I wanted, 2 months ago, maybe you have the timestamp for 2 months ago, or you have the version number from 2 months ago. And these are the changes that were made. Like if you actually went and queried version 13 or queried timestamp as of this timestamp range, then you'll have the table as it was at that point in time, with all of the columns and the schema and whatnot, but nothing afterward.
Does this in any way communicate with, like, if I have a Kafka producer and the Kafka producer is using an Avro schema registry, does this in any way communicate with that?
No.
Okay. So you'd have two different schema enforcements in your streaming topology, right? One from Kafka, one for Spark, and they
Right.
don't necessarily talk to each other.
Right, exactly.
Okay.
Okay.
And what was the error you got?
This was the schema mismatch.
So just in case you guys are curious, we're recording, so in order to make sure that we hear, like either let me give you the mic, or if he has to repeat the question.
And the question was, what was the error that was on screen?
Schema mismatch, the schema mismatch. Okay. Questions? Who signed up for Community Edition and wants to start messing around with some data sets? Really simple. You signed it. Are you on it? Okay. I can show you some really basic things just from like a vanilla notebook. You'll have access to something called Databricks datasets. So take a look at what's in there by doing like a %fs ls and then Databricks datasets. It'll show you all the public datasets that are available for you to manipulate in that Spark environment. And then the specific demo that we did today, we generated the dataset, but something very similar is available under Databricks datasets / structured streaming / events, I believe. Let's see how right I was. Okay, so these are all the data sets that are available to you that are public. And then these are the events that these look like the events that we did in the demo today. So if you just did a head on this file, looks a lot like the stuff that we generated. And then just to read this in, data frame equals spark.read.json, and then the path again was Databricks datasets / structured streaming / events. And then you can do a display data frame, and then you'll see the same type of data that we had earlier.
I know this is a really basic question, but you can export to a CSV and then download a file.
Yeah, absolutely. So you can, right here, download preview or download full results. But is there any reason why you would want to export data out of a distributed system into a CSV so that you have it in a non-distributed system?
Oh, no, just easier to view the data and manipulate it.
Okay, got it. All right, questions about anything that we talked about today, how to get started with Delta, how you might be using it in your environments?
Can you go back up to the ls command? How do we show the?
Yeah. And this is unique to Databricks. So if you did a %fs, that's a magic command for file system, and then you did an ls. and then you pass in a path, like Databricks datasets, then it'll give you, what's sitting out on Databricks file system. Okay, questions? Hopefully this was somewhat helpful or interesting. Please let me know. I'm really easy to reach. I'm just Steven@databricks.com, Steven with a V. If you have any questions about Delta Lake or Spark in general, please feel free to reach out.
Well, thank you very much, Stephen.
Does this work? Oh, that sounds good. Okay, so it's 4:30. I'm going to start. All right. Thank you all for coming. So this talk is about two libraries that live over there. So some background, I work in a robotics lab, so I use NumPy quite a bit for various computational work. As we know, the NumPy system is very widely used. There are a lot of people who use it, a lot of libraries, a lot of support. But as I've discovered, and as many of you have as well probably, is that there are quite a few quirks in its kind of very core fundamentals that are kind of annoying. And after using the system for a bit, I gave up, kind of fixed the issues, and now, for me at least, the system is pretty pleasant. So my use cases and the things that annoy me aren't that unique to me. So hopefully if I talk about the libraries that fixed my problems, they might fix some of your issues also. Okay, so some administrative stuff. So the sources and the documentation live at the main project pages, which have URLs over there. This talk itself is linked there as well. And right, so there's plenty of documentation online, so I would like to not make this into a lecture. So I will try to organize this as a kind of top-level overview so you can see what the capabilities are, and then go read the documentation if you're interested in actually using the system. Okay, oh, too much. Okay, so what am I complaining about? Right, so just a little bit of history. So before Python and NumPy, I was a heavy user of Perl and a project called PDL, which is a very similar computational engine, but kind of for Perl. So PDL has a very nice core design, and just a lot of the kind of basic design decisions are actually very pleasant. The main issue is that Perl is kind of in decline, and it doesn't have that many users. There isn't a lot of library support, and it's very unpleasant in that way. NumPy is very complementary. It has a lot of users, a lot of library support, a big community, but some of the core isn't as nice. So what these libraries actually do, for the most part, is simply to port the fundamental functions for PDL into NumPy. So if you've used PDL before, this is going to sound very, very familiar. Okay, so the main three areas addressed by the first library are just general nice manipulation of arrays to move dimensions around, to concatenate things, that sort of thing. And some nicer routines for very basic linear algebra and for broadcasting. And I will talk about all three. Okay, so let's do an example. So let's say I have two two-dimensional arrays, and I want to concatenate them along their rows. So I want to extend their rows. So, missing one? Oh, interesting. Okay, so I think I'm missing a slide, but that's okay. So let's say I have a NumPy array called AR32, whose shape is 3 by 2, so 3 rows and 2 columns. And if you read the documentation, the function to do this in NumPy is HStack. So H stands for horizontal. So there's also VStack for vertical, DStack for depth, and that's it. If you want anything else, I guess you have to figure it out. So if we give that function, so this is just a NumPy function, those two arrays, what do we expect? So we would like the first one. Do we get the second one? Do we get something else? And fundamentally, is anyone sure what the answer is? I'm guessing probably not, because these functions are surprisingly strange. So when I was writing this talk, I discovered this was actually a trick question, because what happens is that it actually bursts you because it doesn't want the arguments, it wants a list of the arguments. Fine, so if we give it what it wants, so we have an extra set of parentheses, so you get the output that you wanted. So it does indeed look horizontal, and it did what we want. Great. Okay, so let's extend this a tiny little bit. Let's give it 3-dimensional arrays. So I define an array of shape 1 and 3 and 2. So this is a 3D array. It has one extra dimension on the front. And so we can see that its shape is what we expect. And the same question, when we call HStack on it, do we get a nice horizontal concatenation that we expect? Do we get this vertical thing? Do we get something else? Does it barf? Again, I'm going to guess no one is sure what the answer is. So the answer is that. So I called HStack on it, and that is not horizontal. And unless you're an expert in the way NumPy does things, this is going to be surprising. And then, so I'm guessing this is familiar. So it hit a nerve for me, because I kept running into this over and over again. Right, so what if we give it one-dimensional arrays? So let's say I have AR3, which is a one-dimensional row vector of length 3, and then I have AR13, which is a two-dimensional matrix, but that's 1 by 3. So if I HStack the two vectors together, it does what we expect. If I take the two matrices together, it does what we expect also, but if I mix them, if I try to HStack AR13 to AR3, it barfs. So it says that it wants the same dimensions, which I guess you could make an argument that's reasonable. However, if you do the same thing with VStack, it works fine. So it's, and these are very fundamental core functions of the system, and I argue that they should not be this strange. So this is kind of an important question, so I'm going to get a little bit deep into what it's actually doing. So the fundamental problem is that the system is not internally consistent about which is the most important dimension, the first one or the last one. Kind of these numerical algebra systems have a fundamental design decision, which is if you have n objects of arbitrary shape, let's say ABC, and you stack them together, does the n go in the front or does the n go in the back? Either answer is fine, but it has to be consistent. So again, to kind of hammer this point a little bit more, let's say you have a bunch of temperature sensors somewhere, and you put them into an array. So you have a one-dimensional array called T1 that has temperatures in different places. So the shape of that is n locations, because that's how many sensors you have. So this is a one-dimensional array, so the locations are indexed by axis equals 0, so the first axis, and also axis equals -1. So this is one-dimensional, so it's the same axis. Now, let's say you extend this. So you have an array T2, which does the same thing, but over time. So now you have two-dimensional array with locations and times. So you have a choice. Do you have an object of shape n times and locations, or the other way around? So if you were designing this, and you wanted to produce a system that was nice, whatever that means, you would want a couple things. So one thing I would want is consistent printing. So when I print T1, I get locations printed horizontally. So what I would like is that when I print T2, I still get locations printed horizontally. I can get times or whatever vertically, but I would like it to look similar. So that is what I want it to look at. So the way NumPy prints things, that implies that T2 should have shape n times n locations, not the other way around. And this comes just from the way it prints it. NumPy could make a different design decision, which is to print one-dimensional objects as column vectors, but it doesn't. So I claim this is what you want. Okay, so another thing I want is the axis that refers to some property, like locations, should be the same axis in both cases. In T1, the locations are the first axis and the last axis, so 0 and -1. For T2, the locations are in axis 1 and axis -1. So which means that if you want to have a consistent representation that says that when you want to know what the location axis is, if you count the axes from the back, then you can actually be consistent. So in both cases, you can say axis -1 locations, and that's fine, it'll work either way. So those two things together imply that when you stick matrices together, you really want to put your n on the front, and when you refer to axes, you really want to count them from the back. And if you do that, then your world is going to be much more consistent, and you're not going to confuse yourself. And again, this is a design choice, so PDL actually does something different. It counts the axes from the front. It says that the horizontal printed dimension is the first one and not the last one, and it puts n in the back. So that is fine, that is a self-consistent worldview. The issue that is not obviously right is that if you read any linear algebra textbook, a matrix with n rows and m columns is an n by m matrix. And yeah, I got this. Is an n by m matrix. And the way PDL does it is actually backwards. So you can't please everyone, but you really should be self-consistent. And the reason that HStack doesn't work is that it's not self-consistent. So what HStack actually does is it concatenates along axis 1. For a two-dimensional array, axis 1 is the horizontal axis, so that's okay. The reason one-dimensional arrays work in NumPy is that it has special case logic for one-dimensional arrays. But that's it. So if you give a three-dimensional array, you get the strange predictable behavior that you saw. And this is true of a whole lot of functions, of VStack and DStack and all the others. So, right, so what does NPS do? It steals the API directly from PDL, shamelessly. There are two functions, one called glue, which takes any number of n arrays arguments and an axis. And the axis has to be negative. So an equivalent to HStack, to how we think HStack should work, would be to give it a bunch of arrays and say axis minus 1. And then another function is cat, which takes a bunch of things, creates a new dimension in the front, and sticks them all together. So these are kind of simple examples. So you can take, you know, if you take two 3 by 2 arrays and stick them together horizontally, you get 3 by 4. You know, similarly, along the axis equals minus 2, so your three-dimensional cats work. You can mix things together as long as things are kind of internally consistent. And things work mostly the way you expect. So cat is similar. So, you know, so in these cases, I gave it two things. I can give it as many things as I want. So the first, so you get a 2 at the front, and the dimensionality of the rest of it is whatever you gave it. And should also say that this respects the broadcasting rules that I'm going to get into in a bit. And one of those says that you can add as many length 1 dimensions in the front as you need. And what that simply says is that one of something is conceptually the same as something. It's not a crazy thought. Okay, so there are a lot of functions in that area. I'm not going to get into them. Read the documentation if you're interested. So another area that's kind of funny is just general linear algebra. So even matrix multiplication. So up until NumPy 110, which is not that old, the way you would multiply matrices was by calling the dot function. The dot product and matrix multiplication is not the same thing, so I'm not going to get into the strangeness that produces. So in 110, they fixed it mostly by a new function called mapmul. It mostly works, but it still has weird corners. So for example, if you wanted to compute an outer product like that, it barfs. And I claim it should not. So I provide my own function to do multiplication. You can give it as many arguments as you want. It works for the outer product case. It supports broadcasting, that I'm going to get into in a bit. And it's just a nice replacement. And again, there are a couple functions in that area that work. Okay, so I keep mentioning broadcasting, so let me talk about this a bit. So just out of curiosity, how many of you have ever heard of this and know what this is? Everyone? No one? Okay, it's about what I expected. So first let me talk about what this is, and then we talk about why we care about it. So this is a generic way to vectorize functions. So if you have a function that is aware of broadcasting, then when you define the function, you give it a prototype which tells it, is that better? Yes. Okay. Okay. Thanks. Okay. It has a prototype, which means that when you define the function, you define the dimensionality of all of its inputs and all of its outputs, optionally. So when you call such a function, it can compare the dimensions that it expects, because you told it what they are, the dimensions of the objects that you gave it. If they don't match in some way, it'll barf, which is good, because it makes sure you didn't mess up. And the other really important wrinkle is that if you give it an object that has higher dimensionality than what it expected, it will call the function multiple times for each slice, and it will give you an array of the outputs. And if you have such a broadcasting aware function, that happens that happens automatically. You don't need to actually write the loops to do the vectorization, write the checks. That kind of happens by the internal machinery. Okay, so the question was, does that imply that there's some parallelization happening? So the answer is maybe if the implementation does it. The numpy does support it in some functions, in a very small subset that most people don't realize that it does. I want to say that it has no parallelization. My implementations currently don't either, but as you can see, it's a very natural place to add it. So like you can, like especially if this is in C, you can easily add a OpenMP, a little OpenMP pragma, and they'll just do it. So I don't do it today, but you could. Yes, sir. I'll get to that. Okay. The question was about some implementation detail. But first, I want to actually give some examples so we know exactly what it is I'm talking about here. So let's just give an example of a broadcasting aware function. So let's talk about an inner product. It doesn't matter what it is specifically. It's just a linear algebra operation. It takes two one-dimensional vectors of the same size, and it outputs a scalar. So here's an example. If you take 1, 2, 3, 4, find an inner product of it with itself, and you get 30. So if you just give it a single vector, you get a scalar. Sorry, a single set of vectors, you get a scalar. But you can also create an array of shape 2, 3, 4, and then if you give it two of those, it will compute 6 different inner products. Each one will have length 4, which is that last argument. And you would get an array of shape 2, 3 in the result. So I really want to kind of drill down into this because I think this is important. So here's an actual array of shape 2, 3, 4. And then let's also define another array that's just a row vector. And so numpy same provides a broadcasting aware inner. So here I'm calling it. If I give it two of these 2, 3, 4s, there's the output of shape 2, 3. And then the first one is the 14 is the inner product of 0, 1 to 3 with itself. 734 is the inner product of 12 through 15 by itself, and so on. So if you give it identical shape input, it'll do this, but you can also give it single. You can give it objects that have length 1 in the broadcasting dimensions, like A4. So if you compute the inner product of A234, which is a big vector, with just A4, which is just a single row, you get an output of the same shape, but they will be inner products of each row of the big matrix with the one row that we have. Okay, so here's the rules. Mostly it's what I described. I'm not going to get into this. There's a lot of documentation. Okay, so why am I talking about this? So if you read the numpy docs, there's actually a very long, very detailed page that describes what this is. So everything I've just talked about actually is in numpy. The documentation is very explicit, has lots of examples, it does exactly what it is. The problem is that very few functions actually have any support, and so few that most people don't even know that this is a thing and this is an option. And it's too bad because it's a very useful technique. So, so my library provides two different functions. Two different functions to add broadcast awareness to any routine that you have. So one of them is in Python, one of them in C. The Python one is a decorator, like you said. And what the C one does is it generates a bunch of C code that you can then compile into an extension module, and most of things work as expected. So if you have an inner product function, if you already have something called def inner something, and you have a function that computes one inner product, or anything, if you wanted to add broadcast awareness, you simply do that. You add a decorator, you give it the dimensionality of its inputs, so that says you have two inputs, each one has one dimension, and it's n for both of them, which means that the shape could be anything, but they have to be the same. So and the output is a scalar. That's what that empty tuple means. And so now, and that's it. Now if you call this, and you give it a vector of length 5 and a vector of length 3, it's going to yell at you because the dimensions are not what you said they should be. If you give it an upper dimensional object, it's going to do vectorization, and things will just work. And you can apply this to any function you have, and it saves a lot of typing, makes things clear and nice. So right, and the other one is a similar sort of thing. In C, in addition to doing broadcasting, it, by its very nature, has to do Python wrapping. So you get a Python wrapped function that has the broadcasting logic in it. It's pretty convenient. Okay, so I'm gonna switch gears now and talk about plotting. So there's plenty of documentation about the other stuff, and you can see what you need to see. Okay. So yeah, so let's talk about plotting. So as with the NumPy core, there's a dominant choice that people use to do plotting in NumPy, so matplotlib, obviously. So unlike the NumPy core, I'm not aware of anything that is broken with it. So if it's not something that's really annoying you actively, then maybe there's not a lot of argument for using my library. However, hear me out. So my main beef with matplotlib actually is that it's specific to Python. So in my day-to-day, I make lots and lots of plots, and most of them are not in Python, not in NumPy. They're completely separate and live in a separate world. I usually use GNUplot, which is a very old, let's call it stable plotting library. It's very capable, it's been around forever, it's fast, it's nice. But it's just the thing that makes plots. Sometimes I use it directly, sometimes I use front ends. Just because it is a thing that actually creates the plot itself doesn't mean that that is the tool you're talking to. So I'd like to keep using it, and matplotlib obviously because it's on backend. And that has a converse effect in that if you're a matplotlib user and you really like it, you think it makes the best plots in the world, you're still tied to Python. So if all of a sudden you move to a different language, you have to do something else. And it just feels like there's no reason for it. Yeah, so there's that. Compared to GNUplot, matplotlib is actually fairly slow, and that's just because it was written 20 years later. Generally, you see that we're either plotting a lot of data or if you have to replot quickly. For example, if you have a 3D point cloud or something and you're interactively rotating it to look at it from different directions, it's a lot nicer with GNUplot. It just feels a lot better. Finally, matplotlib has an API that's arguably strange. They wanted to imitate the MATLAB API, which is fine if you're a MATLAB user. If you're not, then it just feels weird for no good reason. Okay, so I have this library, it's called GNUplotlib. It is a plotting library that uses GNUplot internally, but you make plots from NumPy arrays. So it's GNUplot, so it looks and feels the way I want it to. It's very quick. It's been around forever, so it has lots of features, lots of backends, and all the various things. I claim the API is better, and if you're a user of PDL, it looks exactly like that, because that's what it is a port of. And I should say I cheated here, because I wrote that too, but we don't need to talk about that. Okay, so just some design choices. So my library just has one function, it's called plot. So if you use matplotlib, it works by constructing the plot kind of a chunk at a time. So there's a whole bunch of functions you call, and then when you're done, you call, I think, show or something, and then you get your plot. So you can do that here as well, but we already have Python. Python is purely capable of adding things to arrays and then passing to lists and then passing them as arguments. So you can build up the plot piecemeal also if that is what you want to do. Finally, my library is a very thin shim around GNUplot itself, which means several things, which means that it is as powerful as GNUplot is. So I don't interpret most of the things, so they just work. It means that I can mess things up if I don't touch them. And it also means learning curve is a little better, because it means that if you know how to tell GNUplot or any tool that uses GNUplot how to change colors in a point or something, then you already know how to do it here, because I just pass the data down directly. Okay, so now I just want to give some examples to sort of get a sense of the API, and then I will be done. So if you want to plot something, you just call plot. So here I defined a one-dimensional array that is a sinusoid, and I just called plot, and you get a plot. So I didn't ask for anything special, so you just get the defaults. So note that this is a two-dimensional plot, so each point is represented by two numbers. You have an x and a y. I only gave it one array, so it knows that it expected two things. It knows that it got one, and in that case, it knows that it should use sequential integers for the domain. So here it plotted it against 0, 1, 2, and so on. If I actually give it, So if I actually give it two different arrays, like here, then it will plot the two arrays in respect to each other. So sine versus cosine is a circle. So here there is a keyword argument at the end. So that's a plot option. Those apply to the whole plot at once. Square means auto-scale each axis together, so not independently. So if I did not pass that, I would get something that looks like an ellipse and not a circle. Okay, so, right. Yeah, so that is what I said. So here we're representing each point by two numbers, an x and a y. You could have more if you wanted to. So let's say we want to have x, y in color. So if you do that, then you say 2 plus size equals 3. So you actually tell it how many points, how many values represent each point. There was a 2 plus size even without, but the default is 2. So if you're using 2, you don't have to specify it. You actually give it 3 arrays. So I actually gave it 3 arrays here. And then you tell GNUplot what to actually do with the numbers. So here I say lines, points, palette. That might look cryptic, but that's just how GNUplot does it. So if you know how it does it, that does not look cryptic to you. Right, so the underscore for with is because with is actually a reserved keyword in Python. So just to work around that, all my option names can have leading underscores that are ignored. So it's just an implementation detail. Yeah, so you can do that, and then you can see that your circle becomes color-coded. Right, so I should also say that you can have a lot more than 3 values per point. Like for example, you might be plotting error bars, right? And then in 2 dimensions, y error bars, you will have at least the x and the y. You will have, and then you will have either a delta, if they're even, they have the same size on both sides, or you can have, 2 extra points if they're skewed. So if you go to GNUplot, type help y error bars, it will tell you exactly the format, exactly how many values it expects, and all that sort of thing. Okay, so that's how you interpret data. So now let me talk a little bit about how you interpret different data sets, and then that's it. So the code and the documentation use the terms data set and curve interchangeably, so I'm going to do that too here. So the full explicit invocation is like this. So you say plot, and then you say curve, 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 and then you have keyword arguments that describe what you want to do with the plot. Each curve is a tuple with data and a dict describing things about the curve, so most of what you expect. And you can put curve options into plot options as well, and those will act as the defaults for any curves that don't specify their own. So here's an example. So here I have 3 different curves. I plot a sine, a cosine, and a line. I label my x-axis and the whole plot. I say with lines, so that is the default one that applies to all of them that don't specify anything explicit, and the line does specify something explicit, so it's point size 1, so that is what you get. And, right, so that is what I just said. So broadcasting is fully supported here, which makes things really nice. So for instance, let's say I want to plot sine and cosine together versus the same domain. So I can do it like that. So theta is my one-dimensional x. Here I catered together sine and cosine, so that thing is actually a 2 by 100 matrix. So there's 2 different rows. One row has my sine data, the next row has my cosine data. So, plot is broadcasting aware, so it expects a one-dimensional thing. It's got a 2-dimensional thing, so it says, oh, I need to make 2 different plots. And that extends to plot options, to curve options as well. So normally legend takes a string, so that is what the curve is called. So normally you give it a string, but I can give it an array of strings, and then that applies as well, and it just picks it up and labels it correctly. So I could do the same thing by actually passing tuples with sine and cosine and all that. It's a lot more verbose and effortful, and this is just nicer in a lot of ways. All right, so now I'm just show one fancier one, and we'll be done. So let's do that. So this is 3D. So it looks like we have two different spiral things. We have different colors. We have different sizes. So that is the code that generates that plot. So I'm saying plot 3D instead of plot. That is simply a shorthand. All it does is call plot with one plot option that says 3D equals true. That's it. The tuple size is 5 because now we have x, y, z, color, and size. So that width directive tells GNUplot what to do. So point size variable, i.e. take the point size from the data. Palette means take the color from the data as well. So z size and color are clear. They're just one-dimensional row vectors. The first two, so cosine of theta is a one-dimensional row vector. NP array of 1 minus 1 is also a row of 2, but I transpose it, so it's actually a column vector. So cosine times transpose of array 1, 1 is an array, is a matrix of 2 rows, first one being cosine, second one being minus cosine. So I do that, I do the same thing for the sine, this thing broadcasts, I get two different spirals, and that's it. So there are a lot more examples. So this mostly just talked about the API. GNUplot is very capable. You can do all the things. It does all the things you would expect the plotting library to do, like 3D stuff, contours, histograms, all that stuff. There's a ton of documentation and demos on the website. Feel free to look at those. And yeah, so the full API docs are on the main page. There's a link to kind of a tutorial gallery type thing that's in the first one. It's all linked together if you just go to the main page. It should all be pretty clear. And that's it. So that's the main page with all of the documentation of the talk and everything else. It's in Debian, so you can just apt install that, and it will just get everything you need, and that's it. Thank you. Questions? Have I made a pip package? I think so. Yeah, you just call it setup pi dist upload or something? Is that it, or is there more? I believe I do. I don't actually use the PyPy repo, so I might have messed it up, but I do believe it's in there. Yeah. Anybody else? So the question was, should NumPy sane be inside the stock NumPy? It could. I mean, there's no reason not to. I mean, one thing you can't do is just fix HStack, is because then that'll break everybody's code. I think it could be there. I haven't tried to do that. If you know the people responsible and want to talk to them about it, that would be fine. Yes, sir.
Does a plot lib support the superimposed plots where you have like a box plot and a diamond plot?
So the question was, does the plotting library support superimposed plot where you, so you mean you would have different plots kind of in this, more than one plot in the same window or something?
Two layers of the same data, let's say. Oh, at least my plot. So my initial plot might be a box plot, and then on top of that I'll impose a 5-line plot.
So I mean, would that be different from something like this? So here I have two different data sets. But the,
Different data sets, but one.
yeah. So they're both lines, but that is a detail. So because, so if you look at this example, so here I plotted 3 different data sets, and the styling is completely independent, right? So here one is plotted with lines, the other one is plotted with points, but it could be, one of them could have boxes or error bars. So this was meant to illustrate that you can put styles into the keyword arguments, and then those are used as the defaults. But you can, every single data set could have its own width setting to do whatever you like. Well, so you would need to either explicitly pass it twice, or you can use broadcasting. You can just put it in once, and then when you're specifying your width line, give it an array. then it'll just do it twice. Anybody else? All right. Thanks.
be like that. All right. Check, check. All right.
It's on now, so
It's on now. All right.
I think everyone can hear me.
Yeah, yeah. Just wanted to stop by and make sure you're all good.
I gave a talk a couple of years ago, and I went back to watch it to see how stupid I looked, and the whole thing was, the AV glitched out, and it went from
This is a different one. We had a bunch of people from the county this time. The open voting was on Saturday, but on Sunday, the guy who came in and talked about how they built all of Los Angeles' infrastructure. And there were like 3 people here, and it was the most fascinating data warehousing talk I'd ever seen. And I was like, this just sucks. You got nobody here, and you got like 3 views on you.
Shall we get started? Sure. Excellent. So we are here for the open source project Data is Not Open Data talk. If you're not here for that talk, we can find a different room for you. I've had this where I was on a flight to Omaha, and then the flight attendant said, if you're not on this flight for Omaha, and someone actually left the airplane after that. I was like, how can you be in the wrong airplane? But I know. So come on, join us, join us. We have free seats here. Okay. Well, if you need to leave, that's fine too. Yeah, of course. So if you want to get the slides, you can email me, and in my auto reply, I have a link to the slides. That's the easiest way. The idea for today is that we're going to talk about how to analyze communities and to talk about the legal and technical challenges and how we can overcome those. And then also about metrics best practices. I have about 57 slides, but we don't have to go through all of them. I would much rather have us talk about this topic together and explore this idea of using community data, open source project data, and analyzing that. So that is where I come from. I want to introduce myself, and then we can go around and introduce each other since we're a small group. I live in Omaha, Nebraska. I earned my PhD there. I was researching open source projects and how companies engage in them and how we can look at community health, project health through metrics. And through this work, we founded the CHAOS project. CHAOS is short for Community Health Analytics, open source software. It's under the Linux Foundation, where we are building out best practices. We are defining metrics for understanding what is community health, and then also building software. We'll get more into that in the last part of the talk when we talk about best practices, because that's what this is all about. I now work at Bitergia. Bitergia is a company out of Spain that has been providing analytics for 8 years now, and they're also a co-founder of the CHAOS project. And yeah, they hired me after I graduated. So I'm very passionate about this whole open source project, analyzing them and so on. But I'm not the expert. There are a lot of people who are much smarter than me on all of this. What I collected for today is what I have learned so far, and I wanted to share that back out. But I'm sure that you all are experts as well in some area, in some fashion. So if you want to go around, just a quick introduction. What brought you to this talk, who you are? Just 30 seconds each, maybe?
I'll go first, and I'll pass the mic. My name is Mark Roden. I am the chair for the Open Data track here at SCaLE. I'm also a data scientist at Ticketmaster. I gave a talk earlier today on how we fight fraud. So that's available on YouTube, which nobody will watch, as we just discussed. And yeah, so I've been coming to SCaLE for a bunch of years now, and it's always a lot of fun.
Awesome. Welcome, Mark.
My name's John Hautzinger. I'm not a data scientist. Well, not really. I do automated quality assurance, auto deployment, testing infrastructure, stuff like that at a company called Whirl. We're a multimedia company. I've been coming to SCaLE for, oh God, I don't know, a number of years.
Long time.
Yeah, a while. And yeah, I just thought this would be a good presentation. I'm
Awesome.
pretty interested in the topic.
Yeah, thanks for joining us, John.
Hi, everyone. I'm Mark. I'm a data scientist for FanDuel Group, working in racing, so TVG and horse racing. I've been coming to SCaLE. This is my 3rd or 4th year. I came to this talk because I'm interested in data, and community building. I am also one of the executive chairs for Pi Data Day LA, which is August 21st to 23rd. Shameless plug, you should all come.
Cool. Awesome. Thanks for joining us, Mark.
I didn't plug it too.
I am Lindsay. This is my first time at SCaLE, so very excited to be here. I am a data specialist, aspiring to be a data scientist at the Getty Conservation Institute, and so I'm currently working on ingesting a lot of conservation science data onto our open source platform that we have. And a lot of the work that I do is primarily data, but I work with a lot of the scientists who are concerned about their data and what they do with it, and being concerned about it being open data and like how you can impose restrictions on that kind of thing. So this is kind of just my area that I'm looking into, also on behalf of our community specialists for that project.
Awesome. Thanks for joining us, Lindsay.
I'm Darren. I've been coming to SCaLE. I think this is the 4th year now. I'm not sure exactly. Just looking at the topic sounded interesting. It sounded pertinent to some of the discussions that were in the open source way earlier this afternoon about the metrics chapter they want to do. So I figured, why not?
Cool. Yeah, I want to know more about that. I didn't hear about it earlier, but
we can.
Afterwards, maybe.
We did a workshop yesterday about it, but he did a talk, Carson did a talk earlier.
Okay.
That was interesting. And one of the chapters is metrics.
Yeah, no, super interesting. Thank you.
Hi, my name is Jillian. I work at UCLA, the library. We have a data science center, and I do consulting with them for GIS. So I want to learn more about open data using QGIS, that sort of thing. And I thought this would be interesting for community building as well.
Awesome. Thanks for joining us. Yeah, we can. I have more interactive elements built in. So I want to invite you onto a journey and start with a thought experiment. Imagine you're a contributor. You're in an open source project, probably to get work done, to scratch an itch, whatever the reason is. And the community is, so the question is how you react. When the community creates a contributor profile for every contributor that shows how much they have contributed. So for every contributor, you can go to a page and it says, you have contributed 3 commits, 5 issues, sent 10 emails, or done 200 translations, whatever it is. Or how would you react if the community regularly recognizes the most active contributors, which then also requires to look at the data, at the metrics? Or what would your reaction as a contributor be when there was a dashboard that showed how active the community is and how that activity evolved over time? So what would your reaction be? If you can pass the microphone so we can have it on the feed, that would be great.
So I think it would depend on a combination of how you're doing things. Is the individual contribution public? So you could go through and scroll through and see like, oh, like you're number 1, you're number 2, you're number 3. Or do you have a dashboard showing like how strong the level of contribution is, and then like these are like the top 5 people? So right, depending on how you display the data and show the data to the community could either create positive or negative reactions. But I think it's all based on how the community is as a whole, right? Doing a leaderboard like in video games is like super competitive. People are like, oh, I gotta get up there, I gotta get my score up, I can't be the last person on the list. So if you had a community that was like that, very competitive, then maybe that's the right way to go. So I think it depends on community.
Interesting thought. Thanks.
I would get very nervous about the metrics getting gamed. I mean, because like I don't know if you remember, like once upon a time, programmers were being judged on the number of lines of code that they would produce.
Yeah.
So you'd write like these 5,000 line files that only did like an addition, just so that you could demonstrate that you've gotten the lines of code. So like the gamification of it makes it that people will play the game rather than make a contribution. And that's where it gets weird to me. Like the most of the contributions I've seen, like where people get recognized, is mainly in conferences like this, where somebody's like, hey, this guy did this module and it's really cool. And it's like, but we're not singling him out as better or worse than anybody else.
Yep.
So
Okay. So you're thinking mostly in the terms of from the community overall perspective. How about as an individual contributor being part of those numbers?
Yeah, that's kind of what I was going to address. Like, I think the first one, if there was a leaderboard or this person is, the top contributor, whatever, it might create a barrier of entry to someone who's possibly intimidated to show their code to someone who's been in there for so long. But also, it will tip the scales while it may be true, it might not be. I think it'll quell a lot of valuable discussion because somebody, say, top 5 contributor comes in and he's like, well, this is how it happens. And somebody who doesn't have like a high leaderboard ranking says, well, no, if you do it this way, it's better because this and this and this. Even though the top contributor's answer could be wrong, he might get more play, and it could hurt the project in overall.
Yeah.
Reset the leaderboard every 2 weeks. But that happens now.
Right.
Like in Wikipedia, like you may be a world expert on Homerian legends, but because it's now what's in the 1928 Encyclopedia Britannica, they won't accept that. Your change.
Yeah. So I just want to get you into the mindset here. Let's have a second thought experiment. Let's say you're at a company. You developed a piece of software, and you got permission. You asked for permission. You got permission to open source it. But your manager has certain expectations if you do this. Your manager wants to see that you're building a vibrant community around it, not just throwing it over the wall. Your company wants to be a good open source participant. And also, you need to be able to identify areas that need attention in the project. So especially as projects grow, sometimes it's hard to identify which modules don't get enough attention. So you need some kind of insights there. And you need to always report progress on how you're doing with your open sourcing the project. So how would you go about doing that? We're thinking about data here. So how would you go about accomplishing these things?
I mean, one way to do this is to track commits, right? It depends on your manager and the language they speak, but you can track commits, you can track the number of contributors, you can track the number of downloads, you can track the number of forks, you could track, like if somebody has a user conference around it, like there's a lot of, you can also track if you actually have disputes, because the more disputes you have, that means you have people who are passionate enough about it to make arguments. So there's a bunch of different ways to measure an engagement from the perspective of how well is the thing doing overall.
Right. Yeah. So you need to think about what you actually want to measure and why you want to measure it. But you need to somehow measure it, right? And so what are we measuring? We are measuring, I'll get to that, but maybe we already talked about this, but what is the data, who are the data producers? And who are the data users in these scenarios? Just think about that for a second. And then what is the relationship between the data, the ones who create the data and the ones who produce the data, who use the data? Someone have a thought about this relationship? So the questions were, what data did we talk about? Right, like commits. We talked about commits or disputes.
So data, everything Mark pretty much said. You could also add like maybe people reporting bugs or feature requests or stuff like that. Data producers would be the community.
Right.
Data users could be both the community and the company. If you're making the data available to the community, like, hey, like this is the health of the community, I think that's interesting for everyone to see. And then go forward a slide.
The next one, the relationship between the three.
Maybe like sort of like a positive feedback loop could be generated, like, hey, this is how we're doing as a community. then the producers can see that and they can see, oh, okay, like maybe we need more. We have a lot of people saying, oh, we want this feature, we want this feature, we want this feature, but no one can fix those features. So maybe now the community the producers go in and say, oh, okay, well, maybe one of us learns to code and that way we can add features to it and add features, and then you get this beautiful cycle.
That's the ideal that we are striving towards, right? But
hypothetical, perfect.
Yeah, no, that's a perfect cycle that we want to get towards. When I was thinking about what is this data that we are actually using, it is often created accidentally because you're not contributing to the project to create data about the project. You're contributing to get work done, to make a change in the source code, to convince someone. So it's very accidental that we are collecting names and email addresses and how many emails were sent. The thing is that we can actually measure are then the contributions themselves, like the commits, the lines of codes created, but also we can look at the metadata about who made those commits, where do they work at, when was the commit made, all of that data that was not contributed as the purpose for making that contribution. The thing that we'll run into here is that the metadata does not have a license. When we talk about open source projects, the source code has a license. But what license do we have on issues? What license do we have for the names and email addresses that are being contributed, that are now part of the Git log? That does not have a license. So when we talk about open data in a moment, that'll come to bite us in the ass again. And then also it contains personal identifiable information, which has legal implications, which we will talk about as well. So is this data that the community produces actually open data? And in my text that I wrote, I claimed, no, it's not. Because we cannot freely use it, share it, because there is no license to that data that was being created. Yeah, go ahead, Mark.
Consider openness to have to do with the ability to share it, or merely that it is existing and anybody can read it? Because those are two different things. Right?
So,
like, if I have access to Git, I have access to all the change logs.
Right.
So I have access to it. Why would I not be able to share it? Why can't I fork that project?
So you can fork the project, right? You can clone the data, but analyzing it has implications because now you're analyzing personally identifiable information. I'll get to the legal issue here in a moment. And then also there is no license around it, so it's a gray area right now. There's no consensus from the research that I've done and from talking with people. There's no consensus that it's that's okay to do it, but we do it, and it's a common practice to analyze open source projects. I'm just saying there are some implications that are coming to surface. I see you're making a face like I'm not getting to the point quite.
No, I'm thinking about, I have several different projects I'm thinking about right now, and they all have different levels of severity, where like some of the contributors, so like for instance, mentioned earlier the voting solutions talk last year at this time, that's intended to be an open source project. And if it's open source, then all this data is open. And that's a project where you absolutely would want to know everybody who's contributing to that project. Like there's legal ramifications of even thinking about closing that data, right? If you're contributing to a voting system, we should know who you are. Like, and there may even be arguments about whether or not we should know your security clearance. And so, but the flip side of it is if you're making a contribution to numpy, the talk we saw right before this, maybe we care, maybe we don't, right? And so like there's a different levels of caring, like there's different ramifications here. That's what I'm thinking about. I'm not saying you're not making your point. I'm just thinking to the next set of steps.
I agree there are cases where we really do care and where we want to make sure we have the permission to analyze the data. Let's talk about the legal side of it. And I'll focus on one piece of legislation that has been talked about. Can you guess which one? Sorry, what?
I was thinking the DMCA, but I'm probably wrong. Digital Millennium Copyright Act.
Okay. I'm thinking about the General Data Protection Regulation, GDPR.
If you're here, you're going to call it CCPA.
CCPA is the California version, which I also have a slide on.
Right, but I'm just saying, you're here. So.
Okay, let's talk about GDPR first. There's a reason why I didn't put CCPA first. There's a reason. So GDPR, so are you all familiar with it? Then we can breeze through this. GDPR defines personal data, which anything that identifies a natural person, the data subject, and processing that data, which is doing any kind of operations. It's technology neutral, whether it's automatic or even manual. It doesn't care. And then there's a controller. A controller decides what operations are being done. This is the person who decides, go out and let's do this. So if you're doing it for someone else, you're not the controller. It's someone else who is directing you on this. Then you're just the data processor. The data controller is the one responsible. So that's just important. And then there's consent. So the data, the persons whose data we are processing, they have to give consent to their data being processed. Now, did someone submitting a commit consent to their name appearing in the Git log and being processed later in having a list of who the contributors are? Is that part of the agreement that we have in open source?
Yeah, I'd say
Implicit?
No, well, I mean, it's if you're committing a git commit, like the whole point of it is it's hashed. Like you can't even back out of that. Like, yeah, I don't even think it's implicit. I think it's explicit. Like you have a PGP key. You have to go through a whole level of nonsense to be able to say that you're there.
Yeah.
That you've made the commit, you've explicitly given permission to grant the ability to look at it, but the further processing, which may be getting these metrics, I think is implicitly granted. So I think portions of what's being generated by making that commit are both explicitly done, and there's some implicit implications that if you haven't really thought that through, I'm not sure I have a lot of sympathy.
Yep. No, that's... I'm on board with your reasoning. Yeah. So, what about email lists? Are you contributing, asking a question on the user email list? That is not the same level that a Git commit has. What about?
It's on Google Groups, man. Like, it's gonna be there.
Well, that's our understanding of it, but the law's understanding does not care about that. Yeah. Right. So the people, our contributors, have certain rights by GDPR. And I'm just doing a very cursory look into this because it's a lot deeper. Key points are transparency, that they know what is being done with the data, information and access to the personal data. So it should not be an issue in open source because it's all open. And then also the right to be forgotten, that they can anonymize the data later or be removed, at least from the processing side. Not necessarily from the open source.
Even then you can't, there's some implicit processing that has to happen for Git. You can't be forgotten from that without changing every commit that came after. You just can't, it's just not possible. The nature of Git just doesn't allow you to do that. There's processing that has to be done to be able to verify that, hey, what is the current state of the tree? You can't be forgotten for your commit unless you change all the data
and that's what all the lawyers looking at this agree on, that GDPR was created for organizations and companies and governments, not open source. They have not fully thought that through for open source. So we are in a gray area here when we talk about open source.
Just to be clear, we're talking about, we're making a git commit. The code itself is not the one being affected. We're talking about GDPR. We're talking about personal, private information about that person, about that contributor. So when we're talking about the contributor, not the code itself, they're being committed, that's a little bit different. So if we're talking about GDPR, are we taking away the identifiers about the person and not the code itself?
In Git, they're the same thing. You can't remove the user without changing the commit. Fundamentally, that's just how it works. The hash changes. The history is different. You have to change the history of the world, effectively. Any potential mirror of that stuff, anything, implicitly, you cannot get rid of it once you've committed it publicly. It just isn't possible.
If someone forks it afterwards, you can squash it. It's not
Like, I understand like what we're talking about here in terms of like what the capabilities are of Git, but there's a serious question here about being able to remove information as a user, as a contributor. And I think that it's kind of being pushed aside right now in this conversation of like, oh no, we just can't do it, so that's what it is. So I think this conversation could benefit a little bit by being a little open-minded to it, being like, okay, what was needed in order to recognize what GDPR is asking, and how can we actually figure that out with Git if that's a possibility?
Yeah, I would like to focus on a different aspect. Let's assume that the data that was created, all the interactions are there, and that's okay. Just let's assume that's okay. Now we are wanting to take that data and analyze it. Now we are controllers of the data, so now we are responsible for giving the rights to the people who contributed to the code, or to the mailing list, or to the whatever we are analyzing from the community, as the people who took the data and are now running analysis on it. The law applies to us if there are any Europeans in the project, right? Because it's only European that this really applies for. So far, yeah. So, and GDPR is agnostic to the fact that the data was already public. It does not care how you got the data. If the data is about a person, then that person has the rights, and you as someone, as the data controller analyzing it or directing someone to analyze it, you have responsibilities now. And we need to get consent. There are two ways to do this. One is opt-in. That is the most legally secured. You get somehow the community members to say, yes, I'm okay for this, my contributions and my interactions to be analyzed, and then you're good. Now, if you think about open source projects that are years old, some people are not even around anymore, not watching the mailing list. It's going to be hard to get consent, especially after the fact. So if you can demonstrate that you have a legitimate reason for analyzing it, let's say you are part of the governing board of a project and you want to help the community and you say this is for the community, then you can make that case that yes, this is in the interest of all the contributors. Then you can offer an opt-out. But you still need to give everyone an option to not be part of that process data. So those are the two options that we have. We're not going to change the data. We just want to have those analytics and see how the project is evolving and doing over time. Come on and join us. Yeah, you can join us. So that's how we are doing with GDPR. So what we need to do is inform our community members that we are analyzing the data before we start analyzing. And I've seen communities do this by posting it on the mailing list, announcing it on calls, writing it into the wiki, making it part of the contributing doc. So everyone is aware this data is going to be analyzed. And then there is this consent at that point when you contribute that you are aware this is happening. And if you don't want that, then you cannot contribute. Or you have to use the opt-out option. But it's a challenge. And again, GDPR was not designed for the open source case. That's the best that I've seen so far anyone try to manage this. Any questions on GDPR? Again, I'm not a legal expert. This is just what I've gathered so far from conversations.
Off topic a little bit.
Yeah.
But effectively, your transactions in a blockchain history could be associated with you personally, couldn't they? So potentially, I mean, you can never be forgotten from that transaction once it's correlated. Isn't that kind of a problem that ties in?
Yeah, I was thinking about that because to your point earlier about being open-minded and so forth, like a lot of the legal arguments about governments breaking encryption have to do with the obtaining of warrants, right, and being able to do due process of law, and how the law assigns rights as well as capabilities to both governments and citizens. And a lot of those legal fictions tend to run up against encryption and tend to run up against hash functions and a lot of these mathematical realities that we live in ways that are not compatible. And so I'm just thinking through what you're saying earlier about this, and but to your point, like if you have a blockchain, if you contributed Git commits, like the way that those technologies work, there is no unwinding. Like that's the way the mathematics are. And so if we wanted to change it, we would have to change the way that the mathematics are applied in Git. And I mean, it's not impossible. I remember other code committing systems before Git, but Git solved all of these problems and became the world leader because it solves so many problems. So I think it now becomes this really interesting question of, you know, are we going to be at the same level of allowing a government to decrypt a phone? It's literally at the same level of, are we going to allow a human to try to remove their signature from this chain?
Right. Isn't it the analysis and use of their data that they opt out? They're not opting out of their data existing in the public. So right.
That's what I'm talking about.
Yeah,
here.
they're not editing. The requirement would be to remove them from Git completely. It would be to remove them from all analysis that is done based on the code, right?
Analysis to do the commit, and I'm basing my work upon their stuff. I'm doing analysis to make my commit to say I'm changing code.
Yeah, but
I am changing their stuff.
I'm thinking about having a dashboard about the community and having reports of how the community is evolving. I'm not thinking about this granular level of work. And if there are 20% contributors that say, I want to not be recognized in this data, we can still use the numbers. They just cannot be tied back to those contributors. We somehow have to anonymize it in the analysis.
Can you say 20% of people did not want to be included, or by not being included?
Yeah, you can say how many are not how many are anonymized, because that does not de-anonymize them. Yeah.
But can you really anonymize it? I mean, Netflix had that same issue, that they were giving out data to try to make better recommendations, and they anonymized the data as best they could. It turned out not to be fully anonymized. Yeah, no.
Yeah.
It
No, that is certainly an
that's
issue.
just how the world works.
Anonymizing, yeah. No, it's a reality issue, I know. And I don't have a good solution for that.
Talk about that last year.
Yeah, there's ways to mathematically anonymize data when you can't anonymize it, right? Like there's a solution to this problem. Now I can't speak to it because I am nowhere near an expert on it, but
it's a little bit outside of what I wanted this talk to be. So
discussion on this outside
yeah,
of here for some of this stuff.
I'm glad. No, that's exactly what I wanted to do. I wanted to get your creative energies flowing, and I want to talk briefly about CCPA, since we are here in California and it is in effect since January. But it says specifically a consumer shall have the right to request that a business. So it's about the consumer and the business. And as an open source project, if you look in the definition of the business, it probably does not apply to you. It has like a $25 million revenue threshold before it applies to you, and some other thresholds. So,
You're assuming a lot about me.
do you have an open source project that brings in that kind of revenue?
But potentially, do foundations fall under that business thing? Because then foundations who that project are on, so that project may not get out. That may not be a get out of free card for that project because they may be under a bigger foundation that does meet those requirements. And you're
Maybe. Yeah.
But does the business rule out nonprofits?
You would have to ask your lawyer probably about
Yeah,
that.
so you
Because
start to
there
get
are
into gray
several
areas where
conditions here, yeah.
or a public
be.
benefits corporation that may be the one that's funding open source by that way, which is not
Yeah.
nonprofit, but the profit never goes to people, it goes to whatever their kind of goal is. So
Right. My point is to say that you need to check whether or not CCPA applies to you, but it does exclude a lot of the, I just want to look at the data. You can look at the data and analyze it. CCPA doesn't care about it. If you do it for a big company or foundation, then it probably applies somehow. So that's why I didn't start with CCPA. So that's what I just wanted to have some legal challenges to talk about, and to say that if you are analyzing open source projects, then it's a good idea to let the community know before you start the analysis. Give them a way to opt out after you demonstrate that you have a legitimate interest. But just be in the sense of open source, just be communicative, transparent, and work with the community on this. So that's my thought, my standpoint. Do you have any closing thoughts on the legal challenges before we move on to the technical challenges? Do you want to use the microphone?
All right, I think that there's a definition problem we're having here when we're talking right now.
Okay.
About analysis of what it means to be analyzing this open source data. So like your definition of analysis is even just viewing a commit that's been made, while there's other sources of analysis that somebody is doing an open source project of analysis where they're taking all lots of different information and coming up with another conclusion. And I think there's different levels of which we can start assessing it through a GDPR assessment because there's different types of analysis.
yeah, well, there's some mathematical analysis that happens for blockchain and for commit that I have to know the whole history. So there's
Agreed, but there's also, there's different levels in terms of the company knowing information, but also external researchers knowing that information. And I think open source brings about questions that should be asked about who is in charge of that data being open source. Is there a solidifying company that it does allow to have that information and also allowed to be able to access it in that way, which they should be if you're actually doing most of that control, but then also being able to control who outside of that initial core is able to access it for that same amount of level.
Yep.
So that's what I think that's the important part to be questioning, not, obviously we can't break a hash and that kind of stuff, so I'm trying to move away from that.
Yeah,
thought
no,
of
thank
this.
you. That's a very good distinction, yeah. Did you want, okay. Then, I know some of you are much more in depth with this than I am. I'm not the most technical person. But if we think about analyzing an open source project, the challenges start with where is the community? How many different data sources do we even need to go to have the whole picture of the community? And that just has a whole bunch of issues when we have different APIs and different places and different tools that we rely on to get data. So if we follow the extract, transform, load model to talk about this, then we need to somehow get the data, unify it, manage identities, calculate metrics, and then visualize it. That's how I broke it out. So if you have any thoughts in the process?
We'll talk after. That's not what load should be. Load should be going to the database, and then you can visualize on top of it.
Yes, strictly speaking.
I know I sound like a total dick, but it matters so much.
Okay.
It's like making your life so much easier in the future. You should have model views and controls as distinct entities.
Okay.
Sorry.
It's there, it's just in like negative 1 point font.
Yeah.
Okay, then transform to me has that load into a database and then viewing, sure, we can put load in here. So when we extract data, that's almost the easiest step when we analyze open source projects. There are, the Git log is, you can easily get that. There's GitHub API, you can easily write a script to query that. So getting the data is not the challenge. Challenges here is if you want to do it over a long period of time, that the APIs change, there are changes to the platforms, and that is where I see the challenge here. You want to add something?
Does Git, the testing that you do, I can't remember the name of the command right now. Or you can do a command that you automatically go through a number of commits to determine when a bug was introduced. Does that, what's that? No, that tells you to annotate. No, the one that you actually say, I want every commit from here and run a test. Git, I used it the other day and I can't remember what it is. It's just escapes my mind. But it automates a way that you can say, run this script for every commit between these, and it does a binary search between those two commits to find where the bug comes in.
I want to know what this is. Yes. This sounds amazing.
It is hugely useful when you need it. But that's analysis, and that is bug finding. That is are you doing analysis at that point? Does that count for this? I don't know. It's just a thought.
That's an interesting thought, but it's not the level that I'm thinking about. I'm not talking about doing work in the open source project, which that is doing work. I'm talking about you want to have some nice graphs for marketing, you want to have a dashboard, you want to report out how awesome the community is. That's what I'm talking about.
I mean, these are sort of standard data science problems.
Right.
Like this is, I think the first, like, the first problem is not this. The first problem is defining what is success.
And until you know what you're actually trying to do and what the success of the project actually is, you're not going to be able to navigate the water of what data format do I care about, which data sources do I care about, which extractions, which transformations, all of that. Like, it's all dependent on what is success to you. Like, what is a successful thing, and how do you gauge how far away you are from success? Once you know that, then you can answer these questions much more straightforwardly.
Yes. I have a slide on that later. So apparently, my way of thinking is a little different from your way of thinking. Yeah.
Oh. Yeah, no, it's like totally awesome.
Git bisect.
Yeah, you give it 2 points in your
Yeah.
history that you want, and it does a binary search, running either a manual step that it tells you to do and you say whether it succeeded or not, or a script that you give it, and it will automatically run tests within your tree and find when the regression happened.
Wow.
That's awesome. I never heard of that. That's great. That's phenomenal.
Yeah, it's totally phenomenal.
Okay.
It is why Git took over the world for some groups. It totally is.
Yeah. So for transforming the data, I know there are a lot of issues. I'm just focusing on a few issues here to get some ideas, because I didn't know what the level of analysis that everyone was doing who would come here would have. But it sounds like you're much more ahead than a lot of people who come to this for the first time. So unifying data there, as you said, Matt, that's just standard problems for doing this kind of work. So I'll skip through this. Managing identities is an interesting one because in open source you have all of the different tools that your community uses, and sometimes people use a different email address, they have different usernames, so you need to somehow merge those different identities that they use throughout the different tools. If you want the level of analysis where you can tie each contribution to the specific people. And then there are certain metrics that you can do just on the raw data that you collected, but other analysis requires you to do some pre-calculations, taking the difference between the first, when the issue was opened and when the first comment was made to see how long does it take the community to respond. So there are some additional calculations that need to happen. And then, sorry that I call it loading data. To me, this is really where we are thinking about how do we present the data, how do we get it out in front of people, who is the data user, what is the most sensible format. Sure, then you can work back to figure out how you actually need to represent it in the database. One of the things that I hear a lot is the data itself is not interesting. You need to tell a story with that data. You need to think about what is the community story and how can you support that with data or refute it with data. Otherwise, you're looking at commits, but what does that even tell you? So I want to also introduce some technical solutions that we have that have already solved these issues. So these are open source projects. You're smiling?
Oh, no. I'm interested in some of this.
Okay.
After having this talk.
Excellent. So I bolded Grimoire Lab because that's the one that I'm most familiar with, and that's what I'm just going to introduce a little bit in more detail. But there's also Chaos Augur. It's a research project at the University of Missouri and Omaha. That's the research group that I got my PhD in, so that's why I know about this project, and because it's part of the Chaos project. Then Apache Kibble. They're providing analysis for the Apache project, and then CNCF has DevStats, which is, I just talked to someone from the community, and they're very much focused on GitHub analysis right now, but are occasionally thinking about other tools, whereas Grimoire Lab, out of all of these, has the most number of data sources that it can pull in, has 30 different data sources, so it gives you the most complete picture. And so if you're thinking about this model, I have managing identities a little outside of the transformation stage here. But the tool, so Grimoire Lab is a tool suite developed by Bitergia, but it's now part of the Chaos project, so it's all open source. Percival is the tool that goes out and collects data, and that can connect to all of these 30 different data sources, and it gives you a nice JSON document. So you can use each of these modules just independently. Grimoire Elk, so it's building on an Elk stack, the Elasticsearch Kibana stack. That Grimoire Elk takes the data, the JSON files, puts it into Elasticsearch database, and then does the calculations and manipulations there, and then stores the enriched data into a separate Elasticsearch index. And then Sorting Hat is the module that knows identities. Sorting Hat, like from Harry Potter, if you've read the book, knows who the people are, or at least you can tell it who the people are. You can find the different identities, connect them, and declare what institutions they're affiliated with so that your analysis can have that level of information. And then Kibiter is a downstream version of Kibana that we customized with some additional analysis features for loading, for visualizing the data. So if we look at this in as a complete flow, then Percival takes in the data, Grimoire Elk processes it, asks sorting hat for the identities, and then we can visualize it in dashboards, or there's even a tool that produces PDFs if you want a static report. And then there's some tools to configuration and managing and all that. Yeah. we love them too. It's very magic. Yeah, we had fun with those. If that's too complicated, there's also a new tool that Bitergia is developing right now. It's free to use for everyone. I just want to, it's building on Grimoire Lab. So you can just go to Cauldron.io, analyze a project. It currently supports GitHub, GitLab. And when we talk about GitHub and GitLab, it's issues and pull/merge requests. And meetups is also down here. So it's early stages. But I'm mentioning it because it's, you just put in your GitHub org or repo, whatever you want to analyze. You have to give permission to get access to your, through GitHub. You connect it, and then it pulls in all of the repositories and starts collecting data. It'll take a while to collect all the data, depending on how many other people are using the server at the time. And then you can go to My Workspace, and you get a Kibana to play with the data. Or there is a link to a public dashboard, which already has some predefined visualizations to start looking. And this is what you can also share out. So that's something that we're building right now. Manrique has built the dashboard and shared it on his GitLab account to where you can just load it into your dashboard to get the chaos metrics. And I'll talk about chaos here in just a moment. And then there's also a forum, community.cauldron.io. I don't know if anyone finds this interesting. I just wanted to show that for people who don't want to set up their own analytics instance, there is a one-click kind of thing here to see some data about your project. It was just presented a month ago at FOSDEM for the first time, so it's still in early alpha. So before we go into best practices and chaos, all that, do you have any thoughts on the technical challenges? So chaos is a short for Community Health Analytics open source software. We started this 3 years ago as because there was a lot of interest just understanding what the communities, how the projects are doing. Are they going to fail in the near future? Is there any risk in using them, or just demonstrating that they're doing extremely well, or early detecting when things are going wrong? And so at the Linux Foundation, we started the project, and our focus is on creating analytics and metrics to help define community health. That is our goal. And we are thinking about this in terms of having metrics. We need to implement them in software, and then we already have software, and we need to define what that actually means so that we can start building some standards across the tooling, and also build out shared language and shared understanding. And when we do analysis on communities, that we reduce friction in this area. Because before, everyone was doing their own thing, and it was a little messy. You have a thought?
I do, but since you've already told me that the success slide is coming, I'm going to hold off for a second.
Okay.
I think I may be about to ask what you're about to say, so go ahead.
So the work is organized in 5 working groups. Depending on the topic that people are interested in, they sort it into common metrics that are shared across the different working groups. We have diversity and inclusion as one focus that we want to understand through metrics. Evolution, growth, maturity, and decline was the previous name for it. We renamed it. Risk, and then the value of open source projects. So that is the categorization that we have, and the working groups in which we define metrics.
Do you define, so like let's suppose you're looking at a project and the project has failed.
Okay.
For lack of a better word.
Yeah.
Would you define, like, are you as part of your ETL, are you creating a labeling system where you can say, this project is in trouble? And so then you would have a labeled data set, perhaps a time series labeled data set where you can show success and failure over time, or a good state or a bad state. Because you're talking about early warning metrics to be able to define when a project is going off the rails. In order to do that, if you already have the states labeled in a time series database, then you can very easily develop models to start doing those types of predictions.
So that is the step where we stop before that step. We are defining the metrics, we're defining the analysis, we're defining how to get the data, how to calculate it, but we're not assigning value to certain values in, or certain impressions of the metric. We're just saying these are the metrics that you can use, and then you have to go in, and we recommend this goal question metric approach, or success, how you measure success approach, where we are providing you with the tools and the metrics, but you have to build out for yourself why you want to measure, and then figure out what your questions are, what your categories of success are, and then build your metric strategy around that.
I feel like you're going to find that most groups are going to ask the same set of questions when they're talking about these things. Like if you're talking about diversity and inclusion, they're going to ask the same sort of sets of questions. And I think you position yourself very well to have a really interesting conversation where you can say, well, you guys may not be aware about this package over here from Switzerland, but they look like very similar to your commit history, very similar to your commit frequency, and they started to have problems and we talked to them, you should reach out to them, right? In which a way you have a meta community of communities.
Mm-hmm. You haven't necessarily assigned meaning.
So exactly, we have not assigned meaning to the metrics because every project is different. So even if we just look at standard metrics around commit history or issue history or whatever, every project has different ways of working that those numbers will look different even though it's the same health. Or that's
a testable hypothesis.
It's a testable hypothesis, but that's what we're working off right now. We're still on the low-hanging fruits, just defining.
You're working on seeing if there's common meaning that can be applied to the metrics and analysis that's being collected and done.
No, he's saying they're not doing that.
No, but you're looking at that. You don't have meaning assigned, but you're looking at it to see if you can, right? Or you're not going to try at all.
So we have tried at the university to collect data and see how projects are doing and try to come up with comparable groups and all that. It has not been very successful. And I know research...
That was going to be my next question. Has it been successful?
So there is research out there that has done what you said with, let's look at, and this is data from SourceForge, ages, okay? So it's been a little dated. But they looked at the SourceForge data and said, okay, these projects all have died. So, and these projects have succeeded. What are the patterns that we see in the data? And the feedback that I've gotten from people who are actively managing communities and maintaining them, they're not finding those criteria very helpful. So, I don't know, maybe it's a fast-changing world or whatever it is that those kinds of analysis have not really stuck.
Are there additional data points that maybe community history, community, just how the community works that change the meaning of some of the same metrics between communities? Is that part of what it is? Is there another, I guess, level of data that's just not easy to capture this way that's missing and that's why you can't just assign it? Or is it that you're changing the data as people see what the metrics are and then they're trying to game the system, gamifying it, and that's the problem? Or it's going to be hard.
It's a hard problem, and our approach is to start small and get off zero. We want to have a better state than having no insights, no metrics at all. So if someone were to start their metric journey, I would recommend to follow the goal question metric approach. You need to know what your success looks like and what your goal actually is, and define the metrics based on that. Don't just look at the metrics and just share a screenshot of a nice graph. You need to tell a story around those metrics You need to tell your success story or failure story or whatever. And then you want to reevaluate your strategy and the metrics that you're actually looking at because the situation changes or you have gaming of the metrics. And so you need to throw out the metric you were looking at to change to something else because that metric has become useless. So those are all things that we need to think about as we're doing this. And I am...
And are some metrics more gameable than others?
Probably.
Should you maybe not publish the ones that are more gameable? Would that be more healthy for your project not to game your metric? There's some really interesting questions there, I think, to discuss.
There are a lot of more things to discuss. We are out of time. Thank you so much for your participation. It's been really engaging. I really enjoyed your insights and just talking with you through these issues that we have. And I hope you have taken something away from it. I certainly have taken away that I need to change my thought on using transform, on load here for visualizing. Yeah. So thank you very much. Thank you. Yeah, we'll put the seats back.